There we go. All right, so the next chapter in the saga of Alfiebot, standing up here, is he's actually been plugged in and online for 2 months straight. Yay! That's a right. That's a first. Almost all the subsystems have been integrated. All the peripherals communicate and share information at 100 hertz communication rate, which was a bit of a challenge. So we've got 100 hertz feedback for the motors and most other subsystems. And the rabbit hole that I've been exploring for the past couple of months is to explore the limits of the SBC that's in his base. So he's got a sorry, I'm on my work laptop. I tried to use my personal one. Let me log out of Teams. So there we go. It's the ROC-5C, Raster ROC-5 ST. It's about equivalent to a Raspberry Pi 5. So it's a small board. After I rage quit another manufacturer's board, I moved over to this one. It has what's called gold support status with the Armbian distribution, so I thought it was a safe bet. It comes with more memory. It has a small NPU, and it has a heatsink, and it all just fit perfectly in it. So instead of solving real problems with the robot, I've fallen down the rabbit hole of seeing everything that I can do on this single board computer. So last month, we talked about the shoulder subsystem, and I demoed that there's a really neat small format neural-based text-to-speech engine that works really well. This month, I'd like to walk you through what I found for speech recognition, or ASR, automatic speech recognition. It's going to be focused on a quietly released NVIDIA project called Parakeet V2. So next chapter is appropriately called What Can We Fit on the SBC? God, it seems like forever ago, but it was also just yesterday. About 3.5 years ago, I did a demo. This was pre-chat GPT, not that I'm patting myself on the back, but it took some off-the-shelf tech from NVIDIA. It was called Jarvis, and for obvious reasons, they had to rename it from Jarvis to Riva. They're modularized text-to-speech modules and speech synthesis modules and some neural stuff. So I MacGyvered together a speech synthesis module that was neural-based and ran on a really beefy GPU. And I tied it together with a NVIDIA Viva speech recognition module. And it was actually really clever. The speech recognition module was divided into 2 parts. Part 1 was to make a best guess as to what the words were coming in as you were streaming audio to it. And then after a little bit of silence, it would pass it through a second neural engine that would attempt to translate that from what it thought it heard into English with punctuation, capitalization, and word correction. And it was really robust and slick and real time, and it made for a really good demo. But that required a lot of computational horsepower. So what I'll show you today is actually recreating that pipeline on a little board you can pick up for like $70 on Amazon or AliExpress. So for up until this point, and this is just one point in ever-evolving evolution of technologies. And as we see these technologies get more powerful and more capable, there's a parallel effort to make smaller format versions of it as capable. If we were to have a conversation a few years ago about whether or not we could do a complete agent-based text-to-speech and speech-to-text pipeline on a small SBC, I would have said it wasn't possible. 3.5 years ago, I could barely fit a large language model that kind of worked about half the time when it wasn't threatening my life in a single or 2 large graphics cards. And as those technologies progress and they find ways of squeezing additional capabilities out of smaller format devices, you may have heard things like small language models, SLMs, to kind of balance out the large language models. we find ourselves running these things on a Raspberry Pi. For the past couple of years, OpenAI's open source offering Whisper was pretty much the only invest game in town for on-device or local speech recognition. They also have an API. You know, you can pay them a couple of bucks and pass the speech packets off to their servers. And of course, nvidia radxa, even though it's a little bit long in the tooth now, had a pretty compelling, robust offering. So this nvidia parakeet, it came out of nowhere without a lot of fanfare. It's a 600 million, not billion, million parameter neural-based ASR module that does combined speech recognition and formatting. And so because it's on the smaller side and it doesn't take as much context as some of the larger ones, there are some limitations already. But honestly, I found it really performant. And before we get into more of the details, we'll do a quick demo to show you how well it works. The next thing I just wanted to get in front of you is this whole discussion of cloud versus local. Now, for some of the graybeards in the audience, we may, and gray-haired ladies, don't mean to appear sexist, I'll poke funny for you, is the whole concept of brains on board. So way back in the day, there was this robot called Anthrobot Topo. Still super cool. At some point, I hope to have more money than Seth to be able to start collecting these things. But it was basically a radio-controlled robot-shaped device, but still cutting edge at the time. And they had promised and really failed to deliver a much more expensive version of that robot called, sorry, I'm hand waving when I could just bring it up. Anthrobot Topo.
It ran on the Apple II Plus.
It did over radio. So yeah, so
radio.
You could program in, you could send speech to it and tell it to drive around with an Apple II Plus over cutting edge at the time. We're talking what, early 80s, I think.
That's an Apple II Plus.
Apple II, yeah, Apple II Plus, Apple IIe. Is it Apple?
That's
Yeah.
8-bit computer that some of us grew up with.
And so the tease and the promise was they had a version of it called Bob, which was an acronym for Brains on Board, right? To actually put a computer in a mobile device. They had some prototypes. I don't even think they sold one. We'd have to ask Thomas.
Yeah, Thomas worked for Alan Bushnell, or
Yeah. Back in the day.
way back.
But so that was the promise and the excitement. Could you actually build a robot and have the brains on board? And this is something we've been tackling since, you know, even before Topo, which is the first, you know, little cornerstone in my young memory about robotics. But it always, the topic comes up: is it better to leverage cloud resources or on-device resources? And really the answer, it depends on what you're trying to do. Now, the short answer is, for whatever computing horsepower you put on device, I can build a more powerful version of that in the cloud, right? Whether it's in the cloud literally or cloud local, like some big computer, you know, sitting on your desk. And that's the fact of the matter. So for cloud, you can throw more horsepower at the problem. You don't have any constraints on size or energy budget or power budget. And so you can leverage things like the trillion parameter AI large language models in OpenAI Cloud or from Cloud or from Google speech API stuff, and not have to worry about having a big enough computer on your robot with enough processing power and second input power to do it. And of course, the negatives of that are it's not on the robot. So if you have a connectivity issue, if your Wi-Fi goes down, if your ISP has a hiccup, or if there's a service interruption, then just, you know, none of that works. So on my side, I do a little bit of pure cloud stuff, but really most of my stuff I call cloud local. I've got a beefy computer sitting at home. So I've got a private VPN that operates kind of like a cloud provider that I could connect to, and that was the basis of my demo 4 years ago. But the promise of having a robot brains on board is really, really cool. So if you're able to find solutions that are good enough on device, then you don't have to worry about anything. You don't have to worry about your ISP going down, whether or not you can figure out how to get your robot to connect to the campus Wi-Fi And then if the campus free Wi-Fi allows you to create a VPN connection back over to it, you don't have to worry about any of that. Everything just works. It's on device. And of course, the negatives to that are, you know, it may not be as powerful as robust as the more, you know, more sophisticated offering on cloud, so it might be a little bit limited. And of course, by doing this processing on device, yeah, the device that does it has to fit on the robot, and you have to be able to have enough power to run that, right? So those are kind of the trade-offs. And there is no right answer. It's based on what you're trying to do, right? So in a setting like, let's say it's a medical caregiver robot that you lease to people who want to maintain independence at home, right? Some aspects of that you may want and insist of being processed locally, things like fall detection, you know, things that you wouldn't want to screw up because you lost connectivity with the server. On the other hand, a lot of those capabilities would be server based, like you're communicating with a home office and you know, a nursing center that's monitoring and stuff. So, and even in a situation where your device is connected to the cloud, there may be some mixture or distribution of those capabilities based on what you need the robot to do and what, well, you know, is it so important if it misses a 30-minute check-in of status? Maybe a little bit less so, as opposed to noticing that the person you're caregiving for is laying on the ground, right? Those things you definitely want to not have to do with excellent cloud. So that brings us to Parakeet V2. It's a little bit of an odd bird, pun intended. There wasn't a lot of fanfare and information about it. It just kind of showed up one day on Hugging Face, and a couple of YouTube talking heads started talking about it. And I won't claim to understand all of the technology that goes into it, but to say that it's a 600 million parameter neural based ASR module, and with the default code, you pass it an MP3 or a WAV file, and it evaluates that, and it evaluates it on this device 7 to 14 times faster than real time. So for all intents and purposes, real time. So as soon as you stop talking, it processes it pretty much in milliseconds, which is really cool. And in addition to pulling the speech out of it, it does punctuation, capitalization. It attempts to make sense of what it heard, but within the context of that one utterance. And if you speak clearly, this version, it gets it right. But much like me as I get older, and you know, some of my friends, is if I don't hear things clearly, sometimes you might miss a word, and that also happens. So one of the other points I'd like to make about this is this whole solution, which works. Hey, perfect, you're just in time. Grab a seat. It works good enough for now. Long term, getting back to the next steps for Alfie is really he's going to have an NVIDIA Jetson at some price point, right, to process these things faster. But just to see how far we can get on a Raspberry Pi 5 has been fairly exciting. The other part of this is that the solution that I've strung together, detecting speech, detecting when speech ends, taking that segment of audio, passing it through the ASR module, translating it into text, and spitting it back out. It's a hint about the right direction, but in terms of where all these technologies are going to end up, it's a stopgap, right? So we're stringing together separate features to accomplish some tasks, such as when we get to the end, you know, a little chatbot. But it also gives us hints as to where the underlying technology needs to go next. So we have a specific piece of code that identifies when speech starts. It collects all the speech. As soon as I detect a silence of about 250 to 400 milliseconds, I'll assume speech is ended. I'll then grab that and pass that on. Really, where you'll see this technology ending up over the next, who knows, 18 months, 3 months, 2 years, is a continuous neural module that doesn't take a lot of processing relative horsepower, identifies the beginning of speech, and then make sense of that speech in several passes, keeping in context the rest of the conversation, right? So, and once that's in place, you can make much better guesses about unsure words about what was being said. You know, think back to the primary example of an Iceman versus a nice man, right? Really hard to suss out even with fluent English speakers. But within the context of a conversation, a future neural-based ASR module would be able to take that additional context and make better sense of that. Hey,
Not sure. There's two spots up there.
yeah, we can set up some more chairs on the other side as well. Yeah, let's yeah, here, let's okay.
Think down that there'll be more, the time goes on, the model will start more and route missing words based on what ethics says.
Oh, yeah.
Yeah, in other words, it's not just not just an language, you know, voice to, or audio to text, but more in
Right. I mean, because we're limited by the available technology that we have, and so we're testing the limits of that. But and I think we're getting some hints with the new robotics world models and the multimodal model, right? So up until recently, it's been finding patterns in the text. Some of the more recent OpenAI models and other ones are incorporating audio, some of these pre-processing audio things as well as images. I think you're going to see a same evolution moving forward as well with ASR.
If the ASR, and then keeping it small enough, that's the key. It will grow. It will grow if it's going to take on more, right? But
Yeah.
hopefully under a billion or.
All right, so what's happening right now is my robot is oh, buddy, it wasn't done yet. There we go. My robot is hosting a Wi-Fi hotspot, and I've connected over to it with a second Wi-Fi card. And then I am connecting over to it using the SSH package from Visual Studio Code. Big Visual Studio Code fan. Oh, yeah. All right, so let's look over here. Let's go and open a folder. Sorry, I should have done this before we started. All right, so I've been kind of going back and forth as to whether I wanted to walk through the code on the ROS side, again, big ROS fan, or before ROS. I'm going to try to walk through the main concepts using the ROS code, but I reserve the right to switch back and forth. And this is not what I was aiming for. Sorry, that was weird. How did that show up? All right, so let's go ahead and pull up a terminal. And so what's kind of cool about this is, for anyone less familiar, is I'm running Visual Studio Code on my laptop, but my laptop is basically running Visual Studio Code remotely off of the robot sitting next to me over Wi-Fi. What I want to do is I want to set up something just to demonstrate what the processor load is right now. So Meetup is a Linux thing. We've got 8 cores. We've got 4 efficiency cores and 4 heavy duty cores. So right now we're idling on the efficiency cores between 4 and 1.8 gigahertz, a nice 35C. And so we'll switch back to that once we start testing out the system. So without boring you with all the details that go into it, we're going to start up a ROS application stack that brings up all of the programs, including the ASR module. Micro ROS agent should not have given an error, but I think we're going to skip that. A little disappointing. Okay, So we're looking at the logging system for ROS right now. So the way I have it set up, and we'll go through the code a little bit in a bit, is that as it detects speech, it will translate that. And I'm cheating a little bit. Again, these are, this is a simple application. As soon as it starts speech, it starts recording, and then as soon as it hears 400 milliseconds of relative silence, it will detect that. So, hey, Alfie, good morning. All right, so if we wanted to start talking about the ASR module on Alfie, we would probably want to start with the radxa ROS-ified SBC.
Oh, yeah, go a little bigger. Control plus.
Oh, sorry, that's right.
Control plus. Susan's turn.
Yeah, so there's a couple things I want to talk about on this. One of the things I'd like to touch on is the voice activity detection technique that I'm using right now, and what Jim's been focusing on, which is wake words. So I think based on what we're seeing here, wake words is probably the way to go.
Yeah, I love wake.
So I'll just.
Do you get back just a string of words, or you get like time points and words?
So there, in this module, there are a couple of different options. As you can get back timestamps with every utterance, which is an option, as well as the second bad module, which does bracketing for the speech as well. So it is an option. I just don't have it turned off because it made it harder to read.
Because if it's 8x real time, you could stop like between words and just send it too much and send it too much. Like have a rolling window kind of spread too.
Yeah, I'll look into it. My current approach is when at completion of utterance based on a silence period of 400 milliseconds, I take that entire audio segment and pass it over to the ASR module.
Yeah, that's what I've been.
But yeah, it's what would be ideal, and that was one of the benefits of the other real time one is you could chunk it out a little bit. Whereas this one, I'm kind of cheating and waiting for you to stop talking.
Sure, yeah.
Oh, you mean like
And that doesn't always happen.
Yeah. So it's fragile, it's brittle, and that's one of the things we'll talk about maybe is next steps for this. Because in addition to a few other things I'd like to try out is another technique called diarization. I don't know why they call it that, but it means doing a little bit of work to identify the distinct speakers in a conversation. Because right now, if any speech it picks up, it's going to pick up and it's going to translate. So that seems kind of basic, and we could probably do better. And I think there is room on the board to memorize speech patterns, speech fingerprints, and to be able to identify the speakers. I think I've got enough room on the board to do that.
So that's like part of your pipeline. You have the gap finder, and then you have the speech transcriber, and you have a speaker identifier, and just kind of orchestrate all of those together.
I'm thinking, yeah, with the current technology, I should be able to do something interesting with that while we wait for the fully real-time neural-based, no interruption, where everything's baked into one.
Oh, so the diarization is a different model right now, unlike when Riva was great, when we tried it out, but we needed a 24 gigabyte video card.
Yeah.
But it had the diarization, and it had the real-time, ASR, and so it could identify who was talking in the group member. I mean, we did a demo of that and then played it back, but it would, but now even the diarization could be available in a smaller model that can run on the CPU.
Yeah.
Or it will be already.
Yeah, so let's switch back over to BTOF here. So in the background, we're running the ASR module in the background. So it's collecting information at very low cost on the CPU. It's collecting packets, and as soon as I stop talking, half a second, maybe. Well, this is 1 second updates. That's all it takes to convert that entire speech. The parakeet module can take up to 25 minutes of pre-recorded speech, which I definitely don't want to take advantage of. But overall, in the processor load, when you're working on a fixed resource device, any kind of a workflow where you can do other things, and once you finish talking, you can process a small period of time. Of course, the large language model that runs on this takes up all the processor for as much time as you're doing it. But yeah, there's enough bandwidth to be able to do some interesting things. I had hoped, I'm trying to get out of the habit of rushing to do something at the last minute just to have it fail, is to have an agent involved demo that you can talk to it. It'll be a chat bot, and I wanted to give it one tool. So Jim's getting a really good talk on using embedding to do command processing on it. What I wanted to do, and I'll have it ready next month, is I wanted to give the LLM and the agent one tool, and that tool's only job is to report back on the battery level, but to do it in a robust way. Anyways, back over here, we're still chatting in the background. So let's take a look at this NVIDIA parakeet module. And again, there wasn't a press release. This is all I have on it. The default model is 16-bit model, of course. There is still a fair amount of heated discussion about whether or not you take a accuracy hit from quantized models. The short answer is if you do the quantization right, it's negligible. So looking through Hugging Face, I found an 8-bit quantized Onyx version of the model, which runs really, really nice. On real GPU hardware, this thing processes things dozens or 100 times faster than real time. On a non-GPU accelerated small board computer with 4 big cores and 4 efficiency cores, it's processing speech between 8 and 14 times real time. So I would say, for all intents and purposes, almost real time.
Almost real time for the on your SBC.
Yeah. Here, let me I'll start putting some of these things in the chat as well. So here's the parakeet. There's a quick link of the demo from last week. So in the list of things to make this work, the default library or example code, you pass it in an audio file and it transcribes it. Great if you're transcribing an audio file, but we want to do a chatbot, right? We're aiming for a robot with a chatbot. So how do you figure out how to send audio over to it? Now, the parakeet module, there's nothing really in it to start processing when it hears speech. It just processes whatever audio file you get. So the technique that I'm using right now is I'm using what's called a VAD, or a voice activity detector. And so this is a much smaller bit of neural code that you can just let run in the background full time. And it has one job. As soon as it identifies speech in the audio stream, it tags it with an audio start, and then it listens. And there's a little bit of configuration into it. You can say things like record up until you don't hear speech for, I think I have it set to 200 milliseconds. And then as soon as those conditions are met, it stops hearing voice in the audio. It waits 200 milliseconds, and it sends a second tag indicating audio in. And so this is the trick that I'm using in this pipeline from listening to the mic to getting to the ASR module. The VAD sits in the background. It listens for speech. As soon as it hears it, it starts collecting the the audio stream, and as soon as it sees the second tag, no more audio, it takes that audio stream and then passes it over to the ASR module as the next step in the process. So why did I do that? I came across that when looking at implementations of parakeet. Someone mentioned that, and there's this one called Silero. So there wasn't that much thought that went into it. That's the one that I use. And I do that because if I don't do that, there's no easy way of getting the right audio over to the ASR module. And even if I did, this ASR module would be chugging along full time, taking up valuable resources, looking for voice audio, and it wasn't there. So VAD's a nice kind of a cheat code to only pass over the audio media. The last thing I'd like to go into is the difference between VAD and wake words. And it gets to what's happening right now. Because right now, the robot's listening, and as soon as it hears speech, it starts recording it, and as soon as it hears the silence, it passes it over. In a chatbot scenario, that would then be passed to the chatbot, and it would do the thing regardless of if you're talking to it or not, or what you're asking it to do. So in other words, there's no way to get the robot's attention, because if you're talking, it has its attention, which is cute. And in a situation where it's just you and your robot in a quiet room, that works perfectly. But in a case like this, where we have a room full of people who are going to talk, it's like having an Alexa without a wake word. It's just going to listen and attempt to do whatever it hears, which
I have a question.
could be problematic. Yeah.
So you just, I was watching it, you just talked like a whole bunch, and it didn't, it kind of was like, I can't get it all out. Is that what happened? Like, I feel like the paragraph should be like this big, because it didn't grab it all.
I wonder if it's because when it's processing through ASR, it's not listening.
Got
Right.
you.
I
Okay.
wonder
So
if
if
that's
it
what
takes a pause, then it,
Yeah, it takes a pause, it has to, my system does the same thing.
Yeah.
okay.
But it's not built for, well, it's not built to record a person's conversation. I mean, like a lecturer. It's
Okay.
made for commands, like the maximum command that you give the robot is a few seconds. You know, you're not gonna go, blah. Now, if you're in a conversation, then, with the chatbot, then you do want to record more. So I kind of, have that as, I figure like at least one sentence is what in other words, it's mainly designed for communication between two entities, either, which is
Not a
one person
monologue.
talks, not a monologue. So you don't need to record 5 minutes straight.
Okay.
That's just not practical. If you do, then you want a transcriber for a speech transcriber, like a lecture transcribe.
Yeah,
That's different.
exactly. It's a very brittle implementation of an ASR pipeline. And it gives us hints at where the technology needs to go next. But basically, in full chatbot mode, this operates like a 1980s speakerphone. Again, you graybeards and gray ladies in the audience remember old speakerphones where you put yourself on speakerphone and you'd hope to Hades that the person you were talking to didn't also put you on speakerphone. Because speakerphones could do one thing at a time. They could either hear you and transmit your audio to the other person, or it could be blurting out the audio from the other person. It could talk or it could listen, and there was no in between. So if you tried talking while someone else was, it was like a walkie-talkie without a button. Because I'm still frustrated about it, is that someone could be talking, but you couldn't interrupt them because your speakerphone wouldn't hear you because it turned off your mic because someone was talking on the other end. You see what I mean? It was very, very limited. But
Half duplex.
half duplex
Another
communication,
old,
yeah. And so at its best, this whole thing is going to be half duplex communication, which is one of the things that I haven't quite figured out how to solve yet. So getting back to the software stack, the stack of applications, the stack of nodes or applications or programs that are running in Alfie. Not to bore you too much with the code, but I have a piece of code whose mission in life is to listen to the microphone for speech and translate that speech into words, and then to send those words out as a message. right? That's all it does. So you launch these stack of programs, it sits in the background, listening for speech, and then here's what it does. I have another module, a speech synthesis module. Again, small neural based, it's resident at the same time. They don't take a lot of processing horsepower. And because generally you won't be listening at the same time you're speaking, it doesn't matter if they take up all the SBC because only one of them runs at a time. But I have an ASR module that's listening for speech, and I have a text-to-speech module that's capable of talking. How do you keep the ASR module from listening when it's talking? And how do you keep the text-to-speech module from talking when it's actively listening to speech? I don't have that quite solved yet, running in two separate programs. Yeah, and so that's the other reason we're not running the full stack right now. Speaking generally, you think like, okay, well, you know, module A could tell module B it's doing the thing, and maybe there's a communications channel that just populates at 100 hertz rate. When the speech synthesis module was talking, it just says talking at 100 hertz, and when listening, and then you listen for the other. That might be a solution, but I think there's a simpler one. I think I'm going to put the text-to-speech code and the speech recognition code in the same program, so that it knows what the other half is doing. So I think that's my next step on this.
Yeah, in mine, I always, when I'm speaking, I disable the listener.
Yeah,
Basically.
yeah.
It's just turned off. I mean, so they don't conflict. Yeah, I mean,
Yeah.
it's just, you can't do two, you know, I think it worked practically fine. Because people, when they're listening to robot, they're not, I mean, I'm not sophisticated enough to let you interrupt the robot, but the robot doesn't have that much to say, you know, unless it's in a chatbot mode. But then I limit the chatbot to one sentence at a time as well. I won't let it go off on paragraphs. It's supposed to be, you know, an interaction, short interactions. That's my philosophy of the robot human. So
Yeah, and like the Alexas and the Google Homes have already figured this out. You can interrupt.
yeah, you can interrupt them.
So I'm sure there's some stuff out there, but for my robot, just based on leveraging ROS, I'm like, oh, I could do a message with hundreds passing, and that sounds messy and complicated. And then I'm like, oh, isn't there a parameter server? Maybe I could publish parameters that indicate the status of the text-to-speech and the speech recognition module. But then a node can't interrogate or set a parameter on another node. That's not how like there's a parameter subsystem in it, so I couldn't do that. I'm thinking just for now, I'll put them in the same piece of code and call it a day, just so it's not listening when it's talking and it's not talking when it's listening.
Mm. Right, you could send messages and all that, but it.
Yeah, see, it even this
You
is
could,
easy
you
right
could
here.
publish a topic. What's that?
Mm.
You could publish in the topic, you know, when it's speaking, I'm speaking, or.
Well, you know what? Let's talk about that for a second. So a topic is a line of communication. You send messages, right? Even if you're not if you're not a ROS person. So if you have a line of communication, you can send a message. So let's say, much like my VAD module sends out an event when I detect speech and it sends out an event when I end speech. Is there a way to get two programs operating totally separately on different processes on different cores in real time? Is there a way to pass single messages like that in a way that it wouldn't be missed? Because what I'd be worried about is that depending on when they come up, if there is a problem with one module, maybe I send a message that I'm listening to speech, but then I die or something happens and I never see the end of speech detector or then it restarts and I never get a beginning of speech again. I'd want to make that robust enough so that
usually, I mean, on an OS, you do that with like a mutex kind of thing, semaphores and mutexes. So you grab it, only one process, you grab it, then you release it. So that it's kind of like a guaranteed interlock.
Yeah.
Because messages.
oh, like a mutex between different programs though. Is there a ROS?
Right.
I mean, that I'm not.
I don't think there's a ROS way. I'm just saying, I don't know.
Yeah.
That's why I started.
Yeah, that's the thing. I'm stuck. I thought
In
parameters.
ROS,
I go. To me, Ross is limiting. I'll go outside of ROS.
Yeah.
Well, I'm sorry. Yeah, I mean, I have a whole Windows project here, that has nothing to do with ROS, and I've achieved 10 times more than I could have in ROS. You know. I can't hear you. No, but even if you're using a ROS system, I'm no longer afraid to jump out, you know?
Okay, well, so I guess what I'm hearing is,
Like
don't worry about a ROS mechanism to share state. Have something else that.
Yeah,
uh,
yeah, I mean, you can code around that and
Yeah.
use ROS when possible, but, and then eventually you're forming a new ROS thing. You know, you could
Yeah.
contribute back, because ROS doesn't have everything. But mutex is between processes. If they don't have that, then
No,
you might
yeah.
want it, and you could add that to the ecosystem eventually. I mean, certainly to your project first.
God, Jim, you're so much smarter than me. I never even thought about doing it outside of ROS.
I don't know, I don't, yeah, I worked with Ross a while too, and you get kind of frustrated and you're like, who's putting up these walls and why am I staying inside the wall? No, I haven't gone out, I haven't even done that yet, but, I've gone outside the wall while I'm in a cross project, but I would.
Yeah, it's a really good point, and that's something that I'll look into, because I love the idea of having them separate programs that just do their thing, but they have to be able to share state between them.
Right.
Otherwise, I just got this non-virtuous loop of talking and then hearing what I said and then spitting it back out and then talking anyways.
Yeah, I mean, yeah, the way I forget how I do it, but it's just like, it doesn't, yeah, it turns off the listening, while I'm speaking, so. And
Yeah.
even hardware can do that, or like, with the microphone array. I was gonna say the microphone, there's also for your VAD, I have a hardware VAD on my microphone.
You know what? I didn't have as
And-
great luck compared to the neural model, but let's compare notes afterwards.
I mean, Oh, you did?
I did, yeah.
Oh,
It's,
because you have a speaker,
same one, yeah.
right? Okay, yeah, no, I implemented that a while ago where I tried to use the bit. They have a bit saying someone is speaking, and incorporated that. Seems to work reasonable, but I mean, nothing's perfect.
Yeah, it's all, finding the best balance.
It's always a state of possible improvement.
Yeah, so I had some setup code here as well. Anyways, but yeah, there was some magic numbers in terms of sensitivity and automatic range and stuff, just to be able to get it to hear me reliably at like a normal distance.
Yeah, I haven't touched it in a while, but it was just I just left that at the default, I think.
Okay.
Just use the bit. But I'll show you later.
Yeah, no, I'd love to compare notes. I keep forgetting that you've been using this mic a lot longer than I have.
The re-speaker V2.
Yeah, so to wrap up on time, oddly enough, for maybe my first time ever, I've got an open question about how to keep the SR module from picking up the speech synthesis. And then I want to put in a large, it's a 900 or 600 million parameter large language model that allows for tool use. Just to see what it's capable of doing. Of course, it won't even hold a candle to any other small language model or the large ones, but just to see how much I can get away with on this cute little SBC board before I move over to some sort of Jetson. And we talked a little bit about large language models and agents and even tools a little bit. The first tool I'm going to give it is a tool that is able to robustly respond to questions about its battery level. The tool will have the battery level at all times, and it'll be flexibly able to understand requests for battery level without having to say the exact right word in the exact right thing, which is kind of another option and a nice segue into Jim's talk, which is exactly that. And not to steal any of his thunder, but when you have a speech recognition module that spits out text, the next question is, what do you do with it? Well, you can throw that into a chatbot and have a conversation. That's almost a given now. That went from an amazing technology 3 years ago to, my Siri does that now. Let's NVD. But from in the context of a robot that you want to do things, that's where things get get complicated, right? So is it a magic word? Is it a magic phrase? If you worked with a Sony IBO or one of the other ones, you had to say the exact thing with the exact phrasing, with the exact intonation, and then it was 50-50 chance it even heard you.
I'm starting up.
And so one of the things I'm very excited to hear about is Jim is exploring a technique to accept and process commands more robustly than saying the exact thing with the exact words at the exact time. So, yeah, I think I'm finishing on time this time. So, next month, oh, I'm sorry, next time I talk, we'll check out the next exciting chapter of Alfie's been awake for 2 months and hasn't been taken apart and hasn't blown up or caught fire.
Yes. All right, thank you, Alan.
All right, thanks.
So it's 10:46. Let's take a small break. If you guys, the bathrooms are right next door for those that have not been in this building before. At 11, we'll have Jim's talk.
My keyboard. Oh. Your goal is to have like, instead of having your emotions felt to the right, that's what you don't want to be your therapist, you don't want to ask other questions about where the roads are, you want to 42, like, if that's your goal, make some of these nothing like a roll in the window and you just constantly.
Yeah, I know it's one of those things where you limit yourself to see how creative you can be, like, because I know this isn't Mario.
Yeah.
But if I can get an agent with some tools and internet connectivity, just to see. Because I'm gonna use that controller.
When I said remote, but it could be.
You get started something great, right?
It's in the kitchen,
Yeah,
right?
we are. I think they could last one. So I have to like.
Oh, yeah, so you're guiding a few things. But it might be a little different than if you were doing the back and forth chat, like the way you interact.
Chatbots are given. That's easy.
But I think that
Okay.
the things like in the room like we're in now.
But
She's that I want to talk to the robot. The idea of trying to make that all work. Because all these things like Jim always the title was
What is it? Like a directional thing that actually turns on a robot where it's like.
Yeah.
Yeah, it's a directional mic. I get attitude and volume as part of the thing.
Well, like, why are
It's an omnidirectional microphone, but I have telemetry on the loudest sound.
Kind of freak out stuff.
Yeah, I get the same way.
To build something inside.
Yeah,
Instead,
you get that.
but also.
Jittery.
Yeah.
Every month.
COVID just stopped, you know, it's all these. First time I did.
Some circles are next, but we should even see the rest of that. Your battery. Time to actually do something.
Oh, what do you think switch to,
LiDAR type.
Disassembled for his entire life. His idea, his conceptualized.
You're right.
I wanted to
You're right, you're right. That.
Yeah, good, glad you guys.
So I think you need to go.
My bad. Oh, right, yeah, well, yeah, we can always carpool if you. Sorry.
Yeah, but what
Future.
And
That was
You
for
do
that
the same type of.
three building or was?
Wait,
Okay,
Yeah,
this
how
is
fast
the
is
stuff
it?
that's done it.
Yeah.
It's got to be quick.
Right, and when they do it, they're doing it for like.
Are those?
He was telling me that I don't like into that.
They blow stuff, it doesn't seem like they're really as smart as natural or anything.
It's game development about, so.
This is in my house? I mean, I don't know, what are we gonna say, you get a, I was gonna get into the car, are you gonna do that?
Stuff that everybody.
If I get a high show, it's not to this house, so it's just to your house, my house.
Yeah. Close to our gate now. Well, you can't just a roll. Okay, so I don't.
Maybe if I'm gonna open everything.
More than your lesson. Okay.
And especially to the imaging.
I got to a point where. I think you can avoid using an SD card now.
Copy bias.
This guy is like this.
What the, like crapping power issue.
It's always exactly.
I would say, and he's worried about.
Of course, limitations
don't. And only. Trying to have a conversation.
But yeah, that's, I mean, that's what I'm like, general knowledge. Or if you wanted to like, have a set of things that could be. And by talking about
A little bit on projects that were.
But I mean, like, even when I was still little. One of the worst classes was.
He wants to pass also any personality or drawing.
We have our,
reading it slowly.
There's something.
big robot.
There's always been some sort of like.
So, something,
Yeah.
Everything else.
And it's not very.
I spent a lot of time thinking about it. Just to have a
Microphone.
Yeah, I've had like.
For me, it's all the other programming, it's not the opposite.
Yeah,
Right?
Like,
you spend a lot of time.
Like,
Alan has spent a lot of time, but you know how much. Yeah.
So they
In
see.
college,
I think he's got a lot better.
I went into college to get a computer.
But I got some like.
Being applied.
Big things like, so I realized it's.
When it was
hosting. So you gotta find the whole. Well, you know, I can do that, like, the machine can build up, that's the process. And I thought,
That was
with it, like, I got my.
Actual kind of video, so I do that same thing.
And that was the first class that I really.
So I wanna like, go to my. On shape and I see where the whole goes. And I export it and I say, here's the whole go. Well, now I want to look at a picture of how it is. My whole. Oh, my head is so. Anyway, he did those. Hard.
And that low level.
We would set up all sorts of
In a way that
for like.
you're not trying.
And I write on the computer.
Very good, hard material.
I should have more trying to discern it out.
Yeah, what I just said, I remember that space time I showed you, it's real shallow because I don't want to mess it up. It wasn't, I could make it really nice.
Yeah.
So this.
That's why I have a lot of like.
The university changed the way that. So now
So-
we're on this one.
So I
Well, I kind of, but my master at the NAP was looking at robotics and something from it, but to say that I did, I shall. Yeah, I mean, because my job is to make sure they work. I had a little bit of exposure on AI, and my company has a lot of information. And I work on the. I have no idea. When I was doing my master, I worked at. I was in my master. It's like, it's all wrong.
It's difficult. It's a programming challenge.
Yeah, I know a lot of guys, putting all their code on. We have a lack of resources over there. I guess, yeah, and professor very well, right? But they don't tell us how. Yeah, it was a lot of hands off. And so we worked with that.
How they make money.
Yeah, you just launched that other one, you mean just the launch of the launch for the, maker fair?
It's not a challenge. It's like a puzzle solving.
Compact. Yeah, I mean, I know there, but I also sent you the.
He was doing very.
Send you the legend. I listened to the picture.
The back of the program is very difficult.
And that was.
Oh, yeah, and so because when I was working there, we were.
But it's still.
Last conversation.
I'll try to send it later, but just, that's it. I already sent it twice.
Even with. I got it.
Yeah, that's what I was trying to figure out.
I showed on when you're building, is there was a problem like.
All right.
All right, there you go. Then I got it.
All right, let's back to the meeting. All right, everybody, let's get back to the meeting. If you take your seats. Jim, when you're ready, take it away.
Hello, everybody. Let's see, me. I guess my camera's on. Hopefully there's enough bandwidth.
Oh,
So-
can you check your focus on?
So my talk today, is, really started its inception from what Seth over here, mentioned to me, the last month, which was, this effort I have to, allow my voice activated robot to take a little bit of leniency in the way the commands are interpreted, or essentially allow the person to speak the command with slightly different verbiage or phrasing, and still be able to do the right command. The problem is in traditional, just old school naive parsing, you just have if else statements. If the person said quote this, or if this word was in the speech, or these two words, or something like that. It's sort of naive way, and it works reasonably well, especially if you use that technique, like if these two words are inside the phrase, then you can at least catch the critical noun verb or something. But what you really want is, I found myself asking the robot, I can't remember what was the command. Here's the command list that I have created over time. And you don't always, I mean, some of these are fairly simple, but some of these you don't remember. Like, is it enable map updating, or is it turn on map up? And sometimes you say turn on and you really meant enable, or that's the literal command. And so it gets frustrating, like, okay, I want this to be more flexible. So Seth had mentioned, embeddings, the concept of embeddings, and I'll go through play a little video. But you take a word or words, you can run them through a lightweight model, AI model, and it will give you back a vector, essentially, big long vector. And if you do that with two different words that have a similar meaning, or two different phrases, they will actually, their vectors will be closer to each other in distance, if you just calculate the distance, which is easy, or cosine distance, and then totally unrelated words or phrases. So those phrases that are similar will be closer. So you can use this mathematical method to determine what's the closest command, or the closest concept or phrase that I have in my list, which I pre-computed those vectors. And then I can compare with the incoming command phrase and find out which one's closest. So here's a brief.
What is Hitler plus Italy minus Germany? This came up in a full video that I did dissecting what happens inside large language models. You see, when tools like ChatGPT process text, the first thing they do is subdivide it in... What is Hitler plus Italy minus Germany? This came up in a full video that I did dissecting what happens inside large language models. You see, when tools like ChatGPT process text, the first thing they do is subdivide it into little pieces, and they associate each piece with a large vector, some long list of numbers. This is called an embedding of that piece of text, and it's helpful to imagine these embedding vectors as directions in some very high-dimensional space, even if we struggle to concretely visualize anything more than 3 dimensions. Models that learn to embed words as vectors like this often encode meaning into the directions of this high-dimensional space. If you take the difference between the embeddings of man and woman, and you add that to the embedding of uncle, you get a vector very close to the embedding of aunt. If you take the embedding of Italy minus Germany, and you add it to the embedding of Hitler, you get something very close to the embedding of Mussolini. It's as if the model learned to associate some directions in this high-dimensional space with Italianness, and others with World War II Axis leaders. What is Hitler plus Italy minus Germany? This came up.
So yeah, that's your brief introduction to
That's crazy.
to embeddings. And so embeddings actually are a very important part of large language model research and all that, because it is a fundamental part of the system to take text and get a representation in math and vectors in this high dimensional space. And so those, this model is trained on in a similar way to predict the next word, and that's how it sort of learns. And let's see, let me go to my. So yeah, here's a little more background. Of course, I'm using ChatGPT, but from what we just discussed, you know, you take a word, like cat, dog, spaceship, you get a bunch of numbers back, and you can you run this model on a lightweight. It's a lightweight model, only millions of parameters. It runs quite fast. So words that mean similar things have numbers that are close together. Essentially, is what it comes down to. And so here's a little. This is a simplified diagram to what you just saw in that video. But spaceship is over here, cat and dog are closer, they're similar. And so my applications, I want to use it for the voice command recognition. So in this case, you might say start moving, please begin to move, or go now. I mean, these are possible ways that you might convey that if you don't remember the exact command. And with embeddings, you convert all your commands into these vectors. And embedding is a large vector. It's a long series of numbers. Let's just call it that, floating point numbers, an array. So you convert all your known commands to these arrays and you save them in your memory. And then as a command comes in, you convert that one. First, you convert it to text, and then with your recognizer, and then you convert to an embedding using the same way you did for the known commands. Then finding the closest one is just basically find the distance, and you can look up how to find the distance between two vectors. It's a very simple formula, or you can use what's called the cosine difference. That's just another formula. You can copy that, and then you run that, and then it will find the closest match. And so this works, I guess I should back up one moment to go back to the my command list. The command list is made up of a lot of commands that are just simple static phrases. There's no variables, right? These are commands that have no information that you supply. Like this one, go to location, that one has a variable. That could be different every time the person speaks, or every time you hear that. Or like load map and then map name. What I'm working on here for this embeddings thing is ones without any variable. They're just simple phrases that have no added information. For the added information, that will be another lecture, probably, and that will use a more sophisticated system like line graph, for instance. But lots of robots have commands that, robots have a lot of commands that are simple phrases that have no user supplied information. So that's what this is for. And so that's how this works well for those commands. So you might say start moving, your voice command, and then find the closest match. And fly to Mars is not going to match, but start moving will be close to the actual command that the robot has. And this isn't one of my actual commands, but so as I said before, this helps the variation how people speak. You don't have to have all that if then. I still have all that if then. I didn't take that code out, but what I do is in my code, I attempt to parse with the if then, and if the person got the exact command, it just does it. If the incoming command does not match any of these, then it runs it through the embedding find closest matched command. And then it runs it through the if then again, and that time it's, if it found one, if the embeddings worked, it's guaranteed to hit one of those if then else's. So that's just a lazy, I didn't feel like changing all that code for now anyway. And right, here's just some more examples. Yeah, and there's a diagram here. They start to move, find the closest match. You can sort of see this space, and then here's these other commands that are in a different location. These are all vectors, of course. And this please begin to move is going to get to the close, or any of these ones, turn left or right, are going to find the right closest command. And yeah, it's just if a little background about this type of model is trained in on lots of massive amounts of text and from the internet and books, etc. And the model learns. This is just a quick background, but through self-supervised learning, the model will learn how to predict the missing word, like the cat sat on the, in this just a sample example on the mat. And eventually it kind of finds out what words, it absorbs the knowledge of what words are similar to each other in meaning by the context, so where they fit in to these sentences. So this is like behind the scenes, the magic of how that model works. And that's through through deep learning. And it eventually will learn that dog is close to puppy, because in the millions of sentences that it's absorbing, that it's reading, it will see all these different contexts of people using the word dog and puppy, and notice and sort of capture that those two are often used in a very similar sentences and similar information. And then you can do things like this: the king minus man plus woman equals queen. So this is just essentially how it's trained. I just want to give you a quick background in how that's trained. So for my system, I'm using Ollama. So I can go on a little sidetrack about Ollama. Ollama can run on my single board computer, quite easily, and it's a nice environment to set up. This is the sort of, you can see the little llama there, and the model I found that was right off the bat the easiest one to find for embedding and this is called a text embedding. So you also have image embedded too. So you can take an image and convert it to a vector, and then you could compare images that way. But I only need the text. So, and this model is 29 million. I'm sorry, that's a million. It's 29 million downloads, but the actual size is only 274 megabytes versus models in the billions usually for LLMs and that sort of thing. So it runs pretty fast. It can run in once you load everything, it can run in half a second or something on a phrase on my computer. On this, it's a single board Latte Panda, which is a little bit faster than the Raspberry Pi 5, but not hugely. And so it runs pretty well. And then everything is available in Python. So any questions about what I've covered so far? I want to give a little opportunity for people. Anything that's not that you don't understand.
So is it embedding like a high dimensional coordinate? Like
Yeah, I mean, a vector, it's a vector which is a list of numbers. And those numbers can be thought of as dimensions, really. So a size vector of 3 is, coincides with R in 3 dimensions. But these vectors have thousands, maybe, or up to I'd say 1024 or whatever. Those are dimensions as well. And so it's super high dimensional space. It's beyond our comprehension of exactly what that means. But the math is the same. The math for a vector of 3 is the same for a vector of 1,000. So you can compare for comparing them and for finding the angle of those vectors. The vector is just a line. I mean, it's just a line with an arrow, right? So it's pointing in some direction. And 3 dimensions, you can think of my arm as pointing in a three-dimensional space. This vector is pointing in this hard to understand 1,000-dimensional space, but you can still easily compute the difference, the distance between 2 of those, or the angle between them, using a standard equation that works for 3-dimensional or even for 2-dimensional. So that's the magic here, is that, and you don't have to worry about understanding that, because that's encapsulated into this neural network. You just give it the text, you get back a vector.
And so if there are 2, and I guess you're passing bits of text, right? It could be a sentence or a statement or a command.
Any text at all.
And so when that piece of text is converted into an embedding, a coordinate in this super high dimensional space, does that mean that if 2 sentences have coordinates in about the same area, that they may roughly be similar in concept?
Right. So as you saw in that little brief introduction video, if you can think about it, back to that diagram, or the diagram I had, essentially similar meaning concepts are going to be closer to each other in the high dimensional space than things that do not have a similar meaning. So that's the magic of what happened in the training of this system, where millions and billions of human written text has been absorbed, and the model distills out this, essentially, the words and phrases, or mainly words, it's tokens, right? But it puts together the phrases. But an individual word, after absorbing all this information, it gains let's just consider it gaining the knowledge of what words are similar, and it records that as the vector. So a vector that is close to another vector, it's just a pointer, right? So this cat and dog are both animals, so they're going to be closer to each other than spaceship. But they still are different, so they're apart. But dog and puppy will be even closer together. Puppy would be right next to dog, say, because they're both dogs. Yes.
So, the size of your vector, in other words, how big a number?
These can be, like I said, can be 1,000 numbers in a vector, an array of, many hundreds, 1,000. That's the size.
We have the size.
That's the number of.
But significant figures of your vector.
Oh, the vectors are their floating point. They could be, 10 significant digits in their, 1.3456, 1.28,
So, but are they short or long?
Well, they're long. They're 32-bit floating point numbers.
Okay, that's what I.
Yeah.
Okay, Jim, so far, like your example shows just single words. When you give it a command, like say, stop recording audio, that's like a sentence. Does it break it down into tokens? calculate the vector for each token and then add them all together to create one large vector?
Actually,
Or
no.
how does?
yeah, it does convert them to, actually, I don't know the full answer to that, but it does convert to tokens. But it's the phrase together is, the vector is found for that phrase. Basically all the text gets put into the model. I mean, you put that all in at once, and it takes that whole phrase and creates a vector for it. So if you have two words together, or three words like this, please move, begin to move, it will get a vector from a single vector from those three words together in that order.
So I'm wondering if each token gets calculated into a vector and then adds them up into one bigger vector? No?
It is more complicated than that. So the large language models have these big context windows, right? And that context window turns into embeddings somewhere in the middle. And that embedding takes into account the order and the meaning and the semantics of the words together to create this combined embedding for that phrase or for the page of the document, whatever your context window is.
Okay, so it's not
Right.
just adding up each.
It's not,
Yeah, it's not just
it's
simple.
not adding,
Okay.
It's more
it
complicated.
takes the whole phrase, and it's treating that thing as a unit. So but yeah, it's like where that phrase has occurred in all of the literature, all of the things that it absorbed, right? That phrase is, it's understanding that phrase from the billions of sentences that were brought in. So,
And the phrase may have never occurred.
Right.
It can understand even though the phrase has never occurred. It's not that it's seen it before.
Right, because it's pattern matching in the middle, right? So in the middle of I'm in the middle of the inferencing of this model, it does convert it to tokens, right? But then each word or approximate word is converted to tokens. But then that combination of tokens in that order goes through that inferencing system. And it's, through the magic of all those weights and biases, it then can, has figuring out the vector of that thing, which it may never have seen before. So that's part of the magic, is that I can give a new phrase that's not been heard, not been trained on. And because of this breakdown in pattern recognition, it will create a vector that's similar to another phrase that I may never have spoken before to the model. But it's just like he said, it's distilling all of this fairly complex high dimensional information that is hard to describe for us. But so now yes, any questions? Oh, I'm sorry.
I just had a thing. There are they have been coming out with just bigger models that take, normally they'll make one word is one token, and they'll in these dimensions they take these tokens and use planar based models rather than vector based models to combine certain tokens together and find the smallest vector.
Oh, so it's a smaller vector than
It's not a vector. It's planar.
planar.
It's a triangle instead of a line.
So it's just three points.
Yes.
Points.
Yeah.
So that's more efficient than.
It's not more efficient. It's not more efficient. It's just higher level. It's more accurate. And yeah, they'll combine two tokens to see if they can create the small size of a vector or planar.
But the planar plane doesn't have as much information as a big vector, right? The 1,000-point vector is 1,000 pieces of 1,000 floats versus.
Yeah, you're instead of. Sorry, I don't know how to put this into words. Do you understand what I'm saying at all?
Yes.
Okay.
But
Just trying to simplify the numbers down to something that's easier to manage, so you're gonna get more accuracy where.
Let me put it like this. In these models, we are trying to find the smallest distance between 2 points in a vector, right? Now we have planar-based models that are trying to find the smallest triangle between 3 points with tokens, between 3 tokens.
Oh you're saying
Like,
how
take the area of the triangle or something.
Yes.
and then-
Yes, they're trying to find the smallest area of a triangle rather than the smallest distance of a line. Between the, and each point would be a token.
and-
Wait, this, are you talking, you're talking about how it works internally,
Uh,
right? 'Cause I-
newer models are, experimental.
That's, okay. That, yeah, in other words, it's a more compact form.
Yeah, there was a recent, update on Olana that was supporting this. It's very efficient with NPUs, or
Okay.
more efficient than CPUs are with.
Then the do one word or phrases, the model you're using has a context one of 8,192. So you can throw it like pages of
You can
text
throw
and
pages,
get a number out of it saying, here's what this page just told me.
Yeah, he's talking about, yeah. He's talking about something more, newer version of this, but the vector thing is what, is sort of, the one that's out and, is, has been out for a while now and it works pretty well and you can incorporate it into your own system fairly easily. So now, I'd like to, well, I'll show you some of what, I've done with Big Orange. And, I've written, a Python module to manage the embeddings. And so you'll see here, might be best to close these. So you can see that I've got like all the command, let's suppose. Oh, that's not the one. It's hard to work with this small window. Hold on a sec.
Yeah, can you just get a bigger screen?
I'll put an order for it.
All right, thanks. You know,
So
right?
Yeah, no, I got it.
Yeah, bigger, just a second. I have to be able to see what I'm doing first.
Yeah, we need an IMAX.
Give you a little more space.
IMAX, yeah. So, this system, I'm listing my commands. So this is where I'm listing all the real commands of the robot. And these are all converted to vectors through this embeddings rather. And then I save those out to a file. And then so I can load them in, and then so this program here, we run on the test. So I've written, this is a piece of this code is inside Orange's system, but I've written a little command line so I can try it out. So I can give a command here, like turn on, let's see, the now updating. And so this will run it through and find first it has to load the model. And so now what you see is it says closest command to turn on updating and enable mapping. And it shows the distance and that's the vector distance between those. And then
You have to have like the threshold, it's close enough.
yeah, I have a threshold that says if it's beyond, if it's higher than this, it's unrelated. So if I say fly spaceship space shop, it's above 0.3, so it's none.
So that's a hand tune, like a magic number.
That's a hand tune number.
Okay.
Yeah. Open or show RGB window. It goes to open RGB window. And so that's this is the basic concept.
That's so cool.
Yeah.
Would like bring up the color display, like no words in common.
Yeah, oh, but may not work.
Yeah.
That's too far.
But that could depend on what set of text you trained it on, like if you had trained it on other text, would it have been a shorter distance perhaps?
Well, yeah, I mean, if I don't get to train it, I'm just providing those commands that are supported. And I'm figuring out, and I'm creating the embeddings for all the ones I know that I have in my if statement. Now, if I decide, sometimes in my actual if statement, I put two different ones that are quite far apart, like in my actual code, and then I could get the embeddings for both of those, right? So then I could widen the net. So if you want to widen the net, you just you just have to do a little extra work in your if statements and add another one. So I could have if the command is open RGB window or is bring up color window. Now those two I've hard coded. Now I can put both of them into the embeddings and catch a bigger net.
So Jim, this is like, we're always doing things with prompts, trying to make the prompt better and stuff, right? So you've got these little 2-word commands. You don't have to be 2-word commands. You can have like 2 sentences explaining exactly what that command does. And then you can have a big sentence, the user of this robot just asked me to do this, or like give it a little more context around it. I wonder if you can play games with your prompting to give it more information to have these things go together better.
That would also widen your net.
Yeah, well, but you're saying in my in the commands I'm creating the vectors for, instead of just doing the 2-word, 3-word, whatever, have whole descriptions.
Yeah,
If the user requests,
yeah,
right, instead of close windows, say if the user requests anything to do with removing windows from the screen.
I would say the user requested to, because you're trying to match, right?
The user, yeah, except.
And then on the other side, you can say the user requested and then give some context around what was going on.
The other, I can't control what the person says. I can only control what it's in this.
You can wrap text around it.
Oh.
The user just asked me this. The user.
Okay, as long as it's fast enough, because right now it's fast, and I don't want to go too slow.
Yeah, right.
Yeah, go ahead.
So I just a little question. What if you put show red, green, blue window? Does it understand the abbreviation?
Yeah, do we have time to play with this a little bit? Like, cause
Yeah,
I'm looking at your command prompts, I wanna poke it with a stick.
Sorry, that's our nature in this room.
And now well, I can also show the live demo of the running robot, but
That'd be awesome.
if you want to see this.
I got a quick one for you. Is there any like method to setting your threshold, or you just play with it? Because obviously the higher the threshold, the more prone to error.
Exactly.
Like, how did you come up with 0.3? Did you just kind of, well, let me just put it there, or is there like a process to where you should set?
Well, so far, I think that was just suggested by ChatGPT or something. I didn't, and then I tweaked it a little bit based on, well, actually here.
So like here, if you had it at 0.33, it would have got those last two. And, like those would have worked, but then how much error, like, is it an exponential? Like if you go to 0.33, I mean, is it an exponentially more error prone?
Yeah.
Is it...
I mean, what ChatGPT suggested was get statistics on all your commands. So I created the min distance, max distance, mean distance, and median distance.
So you have
and that sort of helped a little, but I haven't gotten there yet.
I wonder, now this is, I'm just wondering out of ignorance, right? So you're running the requested command across the entire list. So you have, including this closely similar, like you have a score for each of your 40 commands?
That's right, yeah.
So what I'm wondering is, instead of a threshold, you could do some math to identify the upper limit outlier. Like if maybe you've got instead of looking for a fixed threshold, you could say, okay, well, 19 of the commands are at 0.7, but the 20th command is 0.49. Again, that gentle balance between finding the appropriate response and then just choosing a random
Why
one.
you calculate the R value over that?
You're saying, use the statistics of the whole, well, I mean, all I'm doing now is looking at how close it is. I need a threshold to determine it's none of them, right? It's,
Well, maybe.
because I don't want to match something that is,
You could still have
Too
them
far
at an upper
apart.
bound. Yeah, no, it's something that would be fun to play with.
Yeah. If you've got this floor and it's noisy and you have a spike, probably it's a spike. I think that's what you're saying. If you look for a
I wonder,
spike,
yeah, it'd be a fun thing to play with.
you're saying there's a spike, you're trying to analyze the distribution of the distances across.
Yeah,
Sort of.
yeah.
You can kind of assume that they're asking for one of the things on the list.
Well, they might not be.
Yeah, kind of like a maker.
Yeah, it'd be fun to play with, like go through the commands,
Yeah.
use the distribution, and then like fly my spaceship. And then, like, you could still have like an upper or a lower limit, let's say, for obvious stuff, but.
Right, so then what would it be? Would there be a threshold, no threshold anymore?
Yeah, you'd also want to collect a list of like 100 possible variations of the command as a test suite. To kind of, right?
Oh, yeah, well, I was starting to get into that a little bit, but I haven't, gotten further because.
I didn't think this would work so well. I'm excited.
Yeah, no, it's pretty, I mean, in practice, it works better than this, because most of the time, people are, yeah, he's right, most people are trying to say a command that they know the robot does, because they've read the manual, or at least, you don't give, this isn't like, can do anything. It does a set of things you read about, so you just don't remember the phrase.
Yeah, as someone who's owned 2 generations of IBOs in my time, I was constantly frustrated by my inability to remember the exact wording and tone necessary to get it to do a thing.
you can have a couple of thresholds. One of them is like, yeah, you're spot on, you asked for it. The other one is, I'm not sure, let me ask you, did you mean this? And
Yeah.
then-
Yeah, no, I sort of, so in the actual robot running, I do, let me just get to that.
You can have us.
It'd be fun if it just made up stuff.
Yeah.
Well, I mean, you can make that a ton of the command. Oh, how funny like this.
All right, that's it. After lunch, we're doing the working session. All right.
Hackathon on March.
I invite it, yeah, this is a lot of
I'm starting out.
a lot of potential improvements to be done here, but this is sort of the beginning.
Yeah.
And I'm gonna get into the lane graph.
I could not connect to Slam Tech.
To do those commands that have variables in them, I need to capture what the person said, go to kitchen. Or meet me in the kitchen should also should understand go to kitchen. And then with lang graph, whatever, I'm gonna formulate command, formulate more complex interpretations.
Tools. We're gonna introduce you to tools.
Tools, exactly. So, okay.
Could I ask a brief question?
Yeah, hey, Jim.
What would happen if you instead just used frames of video and had some piece of software you had written that would notice different features in the frame of video, convert each one into a short spelling of some arbitrary combination of text, and submit that as though it were text to what you're using?
What would the video be? This is, what's the video of?
Anything.
Oh, well, again, this
Would it
one,
make sense out of?
this one is a
Same
text.
sense that it makes sense out of.
Yeah, well, this is a text embedding model. They also have, as I was mentioned before, they have visual embedding models or image embedding models. So you can take a picture, it converts the picture, all the pixels, it basically converts chunks of the picture into tokens, runs that through the system, and you get a vector from the picture. Then, so if you have a picture of a dog and you have another picture of a dog, both of those can be converted to the same thing, a long list of numbers, And if you calculate the distance, picture of the dog will be closer to the picture of the other dog than the picture of a person, say. So that's the same thing, except that instead of text being converted into tokens, it converts little blocks of the image into tokens.
Sounds like what I've just described.
It's what you're describing, yeah. They have, except
You're
that-
suggesting it's already done.
yeah, that's been done.
Okay.
And so then, for instance, Orange has a feature where you can, using ChatGPT, it'll take a picture. You say, "What do you see?" It takes that picture, sends it to ChatGPT in the visual, in sort of as a, in using its, using the capability of uploading a picture, and then it gets back a description of what's in the picture. In that process, there is an embedding. That image is converted to an embeddings, and then it's processed after that to get you back through the LLM to get you back a description. So yeah, that's definitely there.
Yeah, but I would like to point out, notice how Jim's robot is smart enough to ignore all of this conversation, because Jim used wake words and I did not.
Yeah, so in my show, I'm going to do a show and tell with that later, but let's see. Hey, Orange, show RGB window. See, parser failed, looking up close.
I assume you meant open RGB window. Okay.
There it is.
Hey.
Let's do another one. Hey, Orange, take a snapshot.
I assume you meant take a picture. Okay.
Nice.
So yeah,
Can you do it when it fails?
yeah, that's the easy part. What do you want to say? Or
Open the color window.
oh yeah. Then it sends that to ChatGPT. So let's see, because now my backup method was what I did before, where I put all the commands into the prompt for the chat bot, and I say, if the user asks something that's similar to one of these, tell them what it is. So that's like the backup. Like I always like tiered approaches. The first tier is the command, you say it literally correct. Second tier is you match the closest. Third tier is it goes to the chat bot and he tries to figure out what you meant. So what was the one you wanted?
When it fails?
Show, well, we already have that, so maybe the
Yeah.
Yeah.
Can you-
no, I want to make it something close enough to something that it can really do so that the chatbot has a chance. Otherwise, it's.
What about someone who pronounces different than you with a different voice won't recognize that?
Oh, I don't know. That may stumble the speech to text as well. But what did you said?
Is there a command for it to speak or to say something or?
Not really. Or what you can say,
Like-
please repeat. Things
Can
like
say
that.
hello?
Can you make it close the window?
Yeah.
Or could I just say shut down the window or something that's probably not gonna get?
I think that there might have been a hang on that command, but
Down versus shut down the window, that's tricky.
I didn't do that on purpose, but yeah, you're right. It's true.
let's say hide. Well, let me. What's another word for hide? All right, well, I'm gonna close that window.
Obscure?
Obscure. Yeah. Hey, Orange. Hey, Orange. Obscure the RGB window.
I assume you meant open RGB window.
It got it. It got the text right.
Probably minimize.
Minimize.
Oh, hey, Orange. Minimize the RGB window.
I assume you meant close RGB window.
There you go.
Let's make it fail. I guess we can make it fail in a glorious way.
Open the picture window. Open the color picture window.
Yeah, all right, yeah. Hey, Orange, open the color picture window.
I assume you meant open RGB.
It's still working. It's supposed to be easy to make it fail.
So the one that Seth said was the red, green.
So,
Oh yeah, let's do that one. Hey, Orange, open the red, green, blue window.
There you go.
I assume you meant open RGB window.
Yeah, I thought, oh, well, what was the one we gave to the?
That was it. That was it.
yeah, so you
Okay.
Oh, I had commas.
have a shutdown command, right? You want to try shutdown?
No, that one is, the shutdown command is off the list.
Okay, all right.
I don't want people just accidentally shutting it down. You have to say that literally. Actually, no, right, you have to say initiate shutdown, but if you say, hey, Orange, shut down.
I assume you meant close windows.
Interesting.
Oh, I think that's causing I might have a crash. There's some, I don't know, I upgraded to Python 3.9 and,
Upgraded to Python 3.9?
yeah, the whole system was on 3.7 for a year.
Oh, okay.
And it went up to 3.9. All right, let's just do this. I can't think of something close, but not close enough.
I'm starting up.
Let's do, or well, wait a minute, we have the command list here. Where is?
I could not connect to Slam Deck. Movement
It's
is
a lot
disabled.
easier when it's moving, because when it's on the floor, it can, you can give it commands like, oh wait, it didn't know go forward or whatever, or go ahead.
That makes me nervous. It's on the desk.
He said,
Yeah.
Hello, my name is Orange.
No, I can take it
Please
down.
be at your service.
Slam take us off.
Well, we're kind of running out of time, so let's just try let's try something. Make it fail. Hey, Orange, go to space. Oh, maybe. Oh, that's probably kicking in. That's kicking in one of those other commands with the variable. Is like go to kitchen.
Oh, yeah.
It should be saying I don't know where that is, but
When you close out Windows, you close this program, this terminal.
yeah, I know that's
Okay,
a
okay.
crash. It's a crash.
Okay, my bad.
What if you mix two together?
Next two commands.
Yeah,
Do this and do that.
yeah, like open the window and
Take a picture.
take a picture or something.
Oh.
Oh, yeah.
Yeah, let's try that. Hey, Orange, open RGB window and take my picture.
I have to open the RGB window first.
What?
Oh, that's because it found the text in there. So, I mean, you had to make this.
It's trying to find you.
Yeah.
He's over there, buddy.
On your face.
Hey, but wait, it interpreted it as two commands.
Take a picture.
Like, is it supposed to do that?
Is it looking for something to take a picture of?
I don't know how it did that. You just discovered a feature I didn't implement. We might be closer to that singularity than we.
Was Big Orange recently struck by lightning? Is number 5 alive? I have so many questions.
Oh gosh, I don't know how.
Now.
And I have to open the RGB window. Oh, it probably parsed to take my picture. It was at the end, and then it needed to open RGB. This is a coincidence. You have to open RGB window to take a picture. Anyway, hey Orange, hey Orange. Oh, something happened. Yeah, it's kind of. Is it not listening? Hey Orange.
Oh,
No.
All right, well, maybe we'll save that for got 10 minutes. You want one more try, or what should we wrap it up?
well, so this is where you're at. What's next?
Oh yeah, I guess we've done enough examples. So the uh, so right, I wanted to mention a little bit of Llama. So Llama works. So that's how I'm doing this stuff on Big Orange. And what's nice about it is it runs pretty fast. It runs pretty well on this machine, and which is, it's a lightweight single board computer. And what's cool about a Llama is you load the model, and it's hosted on a web link basically on your computer. So when you there's a URL. So when I don't need to interface directly with Python code for a Llama or anything. All I have to do is I do essentially a post to the web server, and I give it what the string of text, and then I get back that vector. So it's through a standard web post and function basically. So it's through a web server, and so that makes it kind of convenient. So the web server is running on the computer as this is, well, the Llama. So if you actually go to a browser and you type in this URL, you'll see Llama is running. So through a simple, through commands in your Python, or through a simple call to this post, you open up a web session essentially, and you post some data, JSON data, and then you get back an answer. So it's really and this works for. I also have a full LLM model running as well, and I could maybe show that in show and tell if we have time. But so I have another little test program. I can launch Quen LLM model, like 0.6 billion or 1.6 billion parameter, and through the same interface through the web server, I can have a conversation and all that.
So just to recap, what features are running on the robot and what features are cloud right
now? The only thing that's cloud is the ChatGPT server. So if I'll do that during show and tell, but if you give it a command it doesn't recognize, and it doesn't go through any of that stuff, then it will send it to ChatGPT, and that's on the cloud. But currently I'm playing around with a local Quen, which eventually I'm gonna have that as an option. So
Which one?
Turn off.
Which size?
Whatever.
Is it the 0.6 or the 2 or the 4 or?
No, it's
1.6?
it's the I think 1.6. 1.6. Yeah, I went with the smallest one that was that's pretty good. Not the ultimate smallest one, but all right. Well, thank you. Any other questions? I will stop.
How did you select which model that will make them best accepted?
Which you mean this one here?
Yeah. How did you just pick one and try it out? Or?
Yeah, well, what's cool about Llama is you go to Llama. It has a very good support in their their web page and stuff, and so you can hit this Explore Models, and you can search. So if you type here, say I wanted an image embedder, embedding, and then it'll come up with, if there's any, it'll come up with that. Like if I type text embedding here, then you see the one I'm using there, and there's a few other ones. I just took the first one really because this one is like the most popular. Of course, they're listed in order of popularity, et cetera, et cetera. So yeah, you can search very easily through what's available and for what you want. And you can type different things here, like large language model or LLMs, and you'll get lists of all the different ones that are supported. And so that's a great way. And you have to know what kind of model you want, but other than that, it's usually LLM is the thing you want, right? Anyway, any other? So I recommend Llama so far. It seems very convenient. You can install it on Windows and Linux, and it runs as a server. And the server, like I showed you, it's a web server. It stays quiet and doesn't take up resources until you tell it load this model, and then it starts taking up memory, and then you send it queries. All right, thank you.
I would like to add that the server is OpenAI compatible, so if you have something you already wrote for another service, you can just change the URL to your local host and it'll use Ollama instead, just as if it was OpenAI.
Excellent. Yeah, that's a good point. And that's my goal here is I'm going to be switching over to, well, actually, yeah, that one. Oh, you mean it could be OpenAI, right? Yeah. If you want to use the cloud, in this case, I'm using local.
No, you mean if you use OpenAI, if you want to.
Yeah. If you want to go over to this, right?
It's just point it.
Yeah, you just change it. Yeah. So I'm already on this one now, but actually, I also am using OpenAI for the chatbot, but eventually I want to use the local for that. So I would just switch that URL over from OpenAI to this local one.
Got it. All right, thank you.
Thank you.
So we're gonna break for lunch. If anybody has a show and tell, let me know and I'll add you to the list. If so we are now at lunch. We can be back at 12:45.
All right, is the outpost open?
Are you gonna show it?
All right, school in session?
Yeah. So there's a 7-Eleven, pizza place, corner,
Actually, you got the hand and the.
and other little restaurants.
Recording on.
Yes, recording on. Welcome everybody. We're back from lunch.
Orange.
If you guys could
Your service.
take a seat. So I reserved the very first show and tell spot to continue the Orange Maker Faire talk. Now that we have more members here, Ethan is here. He's the organizer of the Orange Maker Faire. So this year it's going to be 2 days, so it's kind of like a 2-day commitment. Saturday and Sunday, September 13th and 14th. So Jim and I already said that we would commit to both days. So now we're just asking how many other members can join us for either both days or maybe a Saturday and Sunday, because just two of us, it just wouldn't be enough to cover the 2 days.
Is that, does that overlap with our robot meeting?
Yeah.
If the Saturday one does, yes. So I was talking to Jim over here, and I was asking if he can bring his digital computer, his physical digital computer. What do you call it, Jim?
I didn't give it a name. It's just, it uses a single rolling ball. Represents the rising ball of quantum pulses.
So I think that would be a good, showpiece at our
The
booth.
purpose of it is to clock things very slowly, instead of clocking at bigger speeds. It clocks maybe one clock every 3 or 4 seconds. Gives people plenty of time to look at all the different modifications and clocks as they operate.
So
A clever picture of how control logic works, that if you were to try to scope out difficult things to do these days, you can press speeds, like
he
kind
can
of go past you too fast.
multiply numbers, add numbers.
Yeah.
Yeah. And it's a really nice showpiece. So
Well, I'm planning to bring it.
okay, so
I'm gonna need a table just for that. It's so big.
that's okay. We'll give you a table just for that. Yeah. Okay, so Jim will bring his digital computer
Okay, oh, yeah, that, for the show,
for the Maker Faire.
yeah, we haven't seen it in a while, that would be really good.
I think it's a good showpiece.
Yeah, it's the quintessential maker.
Yeah.
I think, one of the,
It is.
at least for computing and physical, and just throw some 3D printed thing, sign on it, and I'll have everything.
I can bring Batsuda, and I don't know if you guys know Batsuda. It was a project that we did here back in the day when AI was still in its infancy. We created a trash classifying robot that uses a camera, and you show it a piece of trash, and it would go through its model, identify whether it was recyclable or trash, and it would open up the right door on this trash cans that it has on it, either the recyclable side or the trash side, and it would audibly say trash or recycle. And it's on wheels, so I can bring that for both days, I guess.
Okay, so item of business number 1, are we going to forego our meeting in September like we did?
I mean, we've done it before. We've done it for the LA Maker Faire. We've done it for the other Orange County Maker Faire.
All right, so.
Yeah, that's your question, because.
Yeah,
So let's start here. I'm in favor of it. Let's just make sure we say it out loud.
Yeah, if everybody, yeah, we have to acknowledge that.
Yeah,
That kills the meat, or, you know.
Yeah.
that one session.
Okay.
There is,
We're good.
you could almost tag team it, like, do the online portion of.
We've tried.
We tried that, it was mixed results.
But yeah,
Due to the loud.
Don't do what we normally do, just have it live at your booth.
yeah, we tried that before. I have a hotspot that I bring with me, but it's very unreliable unless you're gonna give us reliable Wi-Fi there.
Yeah, well, yeah, it turns out we're not the only ones using Wi-Fi and cellular in the area.
Yeah.
There is Wi-Fi there. Unfortunately, I don't have a lot of control over that.
Hey, Walter. Oh, hey.
Thank you, yeah.
All right, here, let me grab.
Yeah, so that's kind of our limitation for streaming from
If
there.
we could figure something out, then I'd be happy to help with that.
Yeah,
Yeah, actually, I'd be more in favor of just, like we committed to the LA Maker Faire, we'll do that in lieu of.
yeah, usually those maker fairs, the large maker fairs, they we meet a lot of people, and that's how we bring in more visitors and members.
We handed out 700 cards at the LA Maker Faire. Wow.
Was it 700?
Yeah.
I love that.
So we
Fair
can
enough.
do it. We can do it again at the Orange County Maker Faire. And yeah,
You can file it around.
Yeah,
around
it's great
Stompy.
stuff, you know, right?
You can
Okay.
have 2 Stompies.
Yeah,
two stumpies.
we could raise them. Sumo wrestling.
Brian,
Oh.
notch.
Was daydreaming over here. Okay, yeah.
Okay, so let's put it on the books. September 3rd, September 13th and 14th. Ethan, when does the application out or?
It's out already.
It's out.
I can talk to you about afterwards if you want to go through it.
Okay,
Next one.
We changed the process a little bit this year, so I can walk you guys through it.
so how many tables are we gonna need this time?
How many you want?
Okay, one for Jim.
Yeah.
Other Jim, do you need a table? Yeah.
Yeah, I mean, I can share, because
So two-
orange is on the ground, but I usually take,
I can share with you, for like small robots.
yeah.
Walter, can you bring one of your
Yeah,
R2s?
I can bring stuff, yeah. Oh, nice.
Okay, so again, it's a 2-day commitment.
Sure.
Saturday and Sunday.
Yeah, I mean,
Okay,
September, yeah, I'd be glad to have you back.
Yeah.
but that's perfect. I think we have enough, to attend.
That's good, yeah, because, we have enough, minimum, or whatever, yeah, threshold of people, and Alan, you may or may not, you may make one day.
Oh, yeah, no, sorry, I was so busy getting set up, I wasn't able to pay attention. I'll be there both days, yeah.
Okay.
Okay, great. Yeah, I mean, the Maker Faire is where we meet, new members and invite new people to the meetings. Get our population up. All right, so that's in the books. So now let's just jump into the show and tells. Jim, you were first.
Do you want,
Want
me to go first or?
you're first in line. Do you
I
need some time?
oh no, I can go, I guess. That's fine.
And just for a heads up, Ross, you are up after Jim.
Let's see, where's one? So yeah, what in addition to that stuff with the embeddings, which I did like the previous month, I think, I had to upgrade. Well, so the story goes like for the embeddings, I needed a llama. For a llama, I needed an upgrade to my Python to 3.9 from 3.7, and then that caused this avalanche of work I had to do on the big orange system to upgrade everything to a new Python, and it killed my my old wait word. So when you say, you see, it's not listening to anything until you say its name, right? And so I was using this thing called the Mycroft Precise, which was a good, decent system, and I had to train it on the hot word, right? Myself, and record like 400 copies of my own voice, and then try to get other people, and then run the training scripts, and then get out a model, and then install and get it into the code, so that the wait, just as Alan was talking about, the wait word system is a separate thing running that listens for the wait word and then hands off and then starts recording the speech after that, and then when that speech ends, which is usually by a pause, detected by a pause, it then sends it off to the ASR, the voice, the speech recognizer. So I use this system called speech recognition, which is a Python sort of stalwart in the called speech recognition. And it's been around for a while, and it supports a lot of different backends, which including Google Cloud and all these other ones, cloud-based, and then offline ones, including deprecated things that no longer exist, like the Snowboy thing is gone. But the one I chose is Boss. I don't know why I don't know if Whisper was even here. I think they've added to the bottom of this list. So 4 years ago, Bosk is based on Caldi Recognizer, which was this Carnegie Mellon University. It's a traditional, or more traditional, old now, I guess, convolutional neural network and recurrent neural network system. But it runs on in the edge computers, so it's very fast, etc. All right, this is not a whole. Yeah, I'm gonna hurry up more, but so that oh, go back. So I found this one called this company picovoice has a wait word system, and you can use it free for non-commercial use, and you can create one wait word a month. But instead of having to train it yourself, you can just type in the wait word, hit train, and you get back a model. And you can even test in real time. Here they have a test, like online console here, and it's a nice commercial thing, but you don't have to pay if you're just using it for hobby use, and you're willing to publish your stuff on GitHub. So I spent some time getting the wait word, and that's what you heard me using before. So I'll show you. Hey, Orange. So you see that I wrote the code that turns the lights on to indicate that the big orange has heard you. And then if you say something, it'll pass that on to the speech recognizer. If you don't, it does the unwind of the lights, meaning that, okay, you didn't say anything, I'm giving up on you for that. And so that, now we can go here. So integrating that, so essentially what you have to do is you have this speech recognition system that is the thing that takes in the voice and converts it to text, and then from there the commands get interpreted. And then you have wake word detector, which is this thing called Porcupine. So you have to integrate those together. So and the driver of the system is the oops, right there. The speech recognition, which is this. So this whole system has a listen function. That's like the main entry point. And the listen function, you can give it a wake word detector as well. So I wrote the code to sort of integrate that wake word detector, the new wake word detector, Porcupine. And it's very, like I showed you, it's very easy to use. And the code wasn't that hard. It's very similar to old code, to the way any wake word detector works. Like, but I added. But what was cool about this is this wake word detector is very. It's a commercial thing, and you could have multiple wake words. So if you train, I have to wait another month before I can train another one. But they did have a free. They have some free built-in ones. So I'm using that. So what I did is I hooked it up so that you can. There's a word called it's an abort word. Okay, so that orange will stop doing what he's doing. As a second wake word. All right, sort of like safe word, right? So I can show you. Let's get some room here. I don't know if it's gonna, a lot of stuff in the way, but hey, orange, go forward 6 feet. Okay. I don't know what the map is looking like right now, but grapefruit, stuffing.
When you're done, you realize how to say it.
Got it. And that would be the comedy aspect. Hey, orange, go backward 4 feet. Okay. And so the response and everything is pretty faster now too, because I did a bunch of work on the BOSC thing so that it preloads and it's a little bit better. Right. But the wake word thing is better. Now I want someone to try it, like Donnie, why don't you try, say, hey, orange, and turn around, or hope you didn't hear me. Oh, it did. Okay.
Oh, parser or something.
I assume you meant, what did you say? I said, I assume you meant, what did you say?
Supposed to be the previous thing you said.
Hey, orange, turn around.
I don't think you heard me. Yeah, see, because it wasn't working too well with different voices. Maybe like Seth, you try it. Say, hey, orange. What's?
Oh, you heard.
Nothing.
The joy.
Never mind.
I assume you meant never mind. Okay.
Say like, what's your status or something?
Hey, orange, what's your status?
This is my current status. I'm at the home location. I'm with Jim. Battery is at 64%. And I'm feeling happy.
It's still Dr. Bruce's code, you know. Right, so yeah, that's good. I'm glad it's working with different people. But so that's the new wake word system. and the new abort thing, which I'll change to, I was gonna change it to, stop now, once I have, you know, I can do that, I maybe leave it.
I like
Leave it.
I like the current one.
Leave it, awesome.
But then other people don't, no, it's, the point is like, if the robot's gonna crash into, something, then someone says, stop now, or just stop. Stop is too short, unfortunately, you can't make a wake word, you need 2 syllables.
You know, it's the same thing with training dogs. You want
Oh.
their name to be 2 syllables and your
Ardo.
your command, because it's easier for their brains to like,
Hmm.
if it's just a short name, like,
Bob.
yeah, and they get confused with something that it rhymes with, like, there's too many things that dog can like miss.
Yeah.
If it's like 2 syllables, they're more likely to like take it in the
Yeah.
first syllable and then actually actively listen to the second syllable. That's what.
Oh, interesting. And that's why when you say, who's a good boy, it's all one.
Yeah.
Who's a good boy, they're like, okay.
Single syllable is a guttural.
Yeah.
It's a warning or an attention or.
Oh, like,
Yeah.
stop, or,
Well, yeah, just like,
Down.
they don't understand the words, but those types
It's
of
the
single intense.
Wonder they don't stop when I say that.
yeah, no should work.
No, oh, that's not 2 syllables, sorry.
Yeah.
Oh, he's saying the single syllables are for warnings, right?
Well, I mean, in dog language,
Like if you say no or off,
it doesn't,
he's like,
there's no linguistic context other than like, be careful, or like, it's not heard as a command. Like even mine is out and I pronounce it as 2 syllables. That's capital for everything. That's,
you say out, out.
out.
Oh. Oh, so a single is doesn't really, it's not effective.
Well, it's
Except for emotional,
not
like,
enough for them to go off. Yeah.
they won't know what to do, they just feel,
Something bad's happened.
yeah. Anyway, okay, any questions about that? So that's the new Porcupine, and, I recommend it for anybody who wants to wait for.
Stopping. I am now near the home location.
I don't know how he picked
Yes, you are.
Not how he picked up grapefruit. Grapefruit.
Stopping. I am now near the home location.
All right, thank you.
All right, thank you.
All right, Ross, you're up next, buddy.
Sorry, is that me?
Yes, sir.
Okay. Hi, everybody. Appreciate always being able to participate in these great meetings and learning all kinds of stuff I didn't know before. Welcome to my basement workshop somewhere north of the 49th parallel in a sovereign country that is still that way, I hope. Not to be political, but why not? What I have today is something that I've actually just started to work on. Like many of you, even though you've got some projects underway, there's nothing like starting a new one just because it's cool. Anyway, what I'm about to show is I've now called it RacerBot, which is based on, actually uses a platform that I bought. It's an RC car, 1 in 18 scale RC car that I bought, I don't know, 5 or 6 years ago when I was tempted to do stuff using the Jetson Nano. They had actually a cool design that produced something that would follow a track around the basement. But anyway, the Jetson Nano has become way obsolete as far as real practical uses, and particularly if you want to use it with ROS, which is what I do. Anyway, so a couple of weeks ago, I guess, I participated in a presentation by the president of the Dallas robot group, whatever it's called, Paul Boucher, who described the platform that many of us know about, the Lino robot, and showed his implementation of it. So I've been interested in the Lino robot all along, and my own current project involving renovating a 10-year-old Turtlebot, I use the Lino robot code format and so on, updated to the the modern repositories, of course. Anyway, after the meeting, the two of us sort of got to talking, and about how you might use the Lino robot with what's called the Ackermann steering, which is the way a car works, and the RC cars work. That came up because I was thinking in my background, I was sort of looking across my messy workshop and saw this car that hadn't been used for several years. So we got to talking. I communicated with Jim Denuzio, who I recall showed us his implementation of the Lino robot in something he called the Truckosaurus, which ran around his basement. And in fact, I think I saw it running down the hallway in your own meeting room. Anyway, one thing led to another. I looked at the design and discovered, hey, I actually could probably upgrade the thing, put a Raspberry Pi where the Jetson Nano was. The Lino robot platform uses another controller. In the original one, it was called a Teensy. And the one, as it turns out, again, like many of us, when a new controller comes along that's only $15, why not? So I actually owned a Pico, and the result was, I'll show it now. It doesn't run, but it sits there on the table, looking as if it would go somewhere. I'm going to let's see. I have a photo booth open here. I need to share the screen, I guess. Best way to do this. Right. Okay, boom. Does this work? Nope. Camera. Right. Oh, it worked before.
You can't say it works at home. He's at home, I know, so we can't say that. It worked before. He got it right.
All right, I'll just use the webcam. Let's see, let's unshare. Okay, I guess if I just take this, right? And
You've got long lifelines there.
I have a cord. Right, so there it is. Ta-da. That is most of you will recognize as just an RC car, and I've added a shelf to it. This is an LD19 that I bought from Amazon, which arrived in 3 days. I was actually surprised how small it is. It's about half the size of the one I'm using on the TurtleBot. There's let's see, how come it's dark? Anyway, there it is. There's a Raspberry Pi in here. There's the Pico that's about to be connected to it. The wheels, let's see, the front wheels, by an Ackermann steering, the wheels turn this way, actuated by a servo. And all four of the wheels are, let's see, if you turn this, actually, the rear wheels are driven by the device called ESC that's driven by PWM. And Jim, much appreciated for code that was added, that he added to the Lino robot platform to generate PWM signals that convert the command velocity messages in ROS to steering and of course forward motion. This is the battery that I bought when this was a Jetson jet racer, and I had to make some modifications to it to to fit the Raspberry Pi. So no promises, but it I'm looking forward to deploying the code that's now available, and of course making it custom to the exact hardware that I have. So that's the show and tell. What do you think, Jim? This might work?
Yeah, that looks nice. Yeah, I like this platform.
Yeah, interestingly, the original Jet Racer has an RC receiver here. The PWM processing here, and they added the Jet Racer had it. This is a Paludo multiplexer. That's sort of cool, actually. It lets you use. Okay, you can switch between using a controller that came with the car, where a switch has been added here that allows you to run the car directly from this, which is a good way to test that the motor and the battery and all that work, or position it somewhere in your room, or you flip the switch and it becomes autonomous, run by the ROS that's going to be loaded onto the Raspberry Pi. So no promises as to when the next the live demo will be, but later, probably later than sooner. But here we go. So there we go. Jet Racer bot.
Very cool. Thanks, Ron. Thank you.
All right, Alan, you're up next.
Next.
All right. Spotlights. Share. All right. So actually, I've got two things I want to get in front of you. I'll try to make them quick. The first one is, it's obvious to anyone in the industry that AI is going to eat the world. The lead time is only for society to catch up to its capabilities, and then it moves on. So I ran into a problem last week, and I wanted to walk you through how ChatGPT O3 helped me to resolve this, and to show you something that somebody may not realize that's within the realm of capability for these chat models now. So ROC-5C, the SBC in Alfie, super awesome. I chose it specifically because it's considered a gold tier support for Armbian, which is my current favorite Linux ARM distribution. So here's Armbian. Gold. Yeah, Armbian, super awesome, platinum support. So moved over to it, bought the board, been totally happy with it until last week. I do a sudo apt update, sudo apt disk upgrade, which updates all your software. And after a reboot, there was no more Wi-Fi and no more Bluetooth.
That's just like what the problem we were having with the other one.
It is. And
With those units.
And so this is exacerbated by the fact that this board is locked up in the bottom of the robot with only a serial TTY adapter. There's no HDMI, there's no keyboard attachment. There's no way to get to it. And so I connected up through my serial TTY. And so just for some background, I've used Linux for decades. Like I understand the basic concepts, but I'm not a master of any particular subsystem. So I've rebooted. There's no Wi-Fi, no Bluetooth, no Wi-Fi or Bluetooth device. And something that was posted in November of last year no longer worked. And I have to present this Saturday. So what do? I go to ChatGPT. Now, hopefully all you guys have an account. If you don't, sign up for one. It's free. It's more helpful than you realize. Now, if I were to look over your shoulder, I would hope to see a long list of recent chats as you learn the capabilities and limits and how it can help. It's a sign of a healthy partnership with an emerging technology. Now, so I do throw them a couple of dollars every month. I think they're doing really great work. And one of the models available on the paid version is O3. So all of these are chatbots, large language models. what makes O3 a little bit unique is its ability to formulate questions, search the internet for relevant information, and consolidate and summarize that into an answer, right? So this isn't just chat box, tell me an answer. The chat bot is actively going to scour the internet based on everything it knows to close that gap. And so here's how I framed it. I recently updated, so I no longer have Wi-Fi. Can you help me troubleshoot your Wi-Fi or fix it? And I realized I didn't get enough information. I said, oh, I'm running a review. So with that information, it does a little bit of thought. It does a little bit of troubleshooting steps. It uses that information to run a couple of web searches, including relevant forums and information. It does a second search through the web. Now, mind you, it's not shooting off the cuff. It is actively looking for relevant information on the internet. That's what makes O3 a little bit unique. And it comes through, it tells me more about the chipset, which I'm painfully familiar with from the Nova board that I rage quit earlier, driver status. And it's like, hey, try these things. Yeah, no problem. So again, I recognize the fans.
Thanks.
Huh?
Yeah, very similar. Remember, you know that email I sent you? I got the Nova working.
Yeah.
Now with 2404.
Perfect.
Because somebody found out that some person found out that if you just after boot up, you try to initialize the Wi-Fi driver a second time because it tried it at the boot up, it actually connects or it works.
Turn that
and
into
it's a kernel error.
service script and
Yeah, I turned it into a boot up script. Of course, I needed to plug in the HDMI and whatever. I mean, there's no other way to.
Yeah.
I had to, but that was when the board was outside, hasn't been integrated in anything yet.
Yeah, Rockchip is kind of a turd when it comes to community support and board support. That's the consensus from everyone in the know. And with the new 6.x series kernels, there are a bunch of errata and stuff, and everyone's struggling to keep up. So
yeah, it's a kernel-based problem.
Yeah.
In the Linux 6.6 or kernel, or I think, or whatever.
Yeah, so it goes through and it recommends a couple of things. Now, I'm not going to drain the entire interaction, but it does a couple of things. And so I respond back. I just paste in the DKMS status and it confirmed what's changed. So again, I'm not necessarily expecting ChatGPT to solve the problem for me, but I'm partnering with it. It has access to more information than I do. I'm not a subject matter expert in Wi-Fi, nor do I want to be. Oh God, I need to make it work so I can get back to working on my presentation. So over the course of a couple of chats, we figured out where was the salient part. So a little bit of driver install. It found a posting that said that there was a recent change in the kernel that required a corresponding change in the driver.
Yeah.
And it walked me through to remove the driver module and then rebuild it. And let me find it. So the first thing didn't work. It's going back through again. Here we go. It found the edit that required. Basically, one of the function calls needed an 11th parameter. So after collecting that information, it gives me a series of steps. It wants to make sure I have build headers. That would have been a little bit more helpful before I lost Wi-Fi, but I already had them. Go to the source directory, which was correct. Run a sed to update the function call. Now, I'm not super comfortable running commands I don't totally understand, and I don't understand sed a lot. So I went into the file and edited it manually.
Yeah, you don't.
Same end effect. And then it walked me through to remove, add, build, and install the USB drive again, and then it had it reboot. So like this is what I wanted to point out to you guys. In the evolution of large language models and agent and agentic capabilities, this is something available now in a real world situation. I didn't frame this as I want to have something cool. I didn't know where to go next. So I partnered with the AI. The AI scoured the internet faster than I could. And working with the AI together, we solved the problem with far less frustration than if I had to Google search my way through it. So as a result of this, I posted to their Discord and I'm like, hey, your gold standard board, you're kicking out the Wi-Fi by pushing out an updated build. Who knows, do anything about it? So I turned this into a script. And I checked my sudo apt update and upgrade. And if anything involves the ambient firmware, I run the script and then reboot and fine. But like this right here, isn't it just guessing? It's scouring the internet, finding relevant information, walking me through troubleshooting steps, taking the results of that troubleshooting step. And after 3 or 4 iterations, it solved the exact problem perfectly. So I just wanted to show you guys if you're not actively tracking the limits and capabilities, this stuff is available right now. And it worked. Saved me so much frustration. I'm still frustrated. I bought the board because it was supposed to be platinum.
Yeah, and then you rage quit the first one to go. You went a harder problem.
There's nowhere left to go.
But yeah,
Time to buy a Jetson.
but it's kind of, it's somewhat ironic, I guess, that you switched to get away from the problem that we were both having with the Indie Droid, and then it hit with a harder one. And the Indie Droid one, I found a person that just said, reload the driver. That's it. It works. And well, he said, reload the driver. And it was not 2404 LTS. It was some other similar, one of the other versions of Linux that they were supporting. But I figured, you know what? It's worth a try. And I did it and it worked because it's a problem in the kernel side, and so it applies to multiple different Linux versions.
Yeah, it's a recurring issue, and Rocket just hasn't been as helpful.
And I didn't have to modify the driver, luckily, or going through all that. But somebody's it's critical to find those comments. Now, I think for me, I didn't use ChatGPT in this case, I may have used it somewhere, but I found links of people discussing the different forums. And sometimes your human skill if you're good at going through forums and finding stuff, you might get to the answer quicker than ChatGPT's long-winded thing. If you see, that guy said this, I'm going to try that, because I had to go, well, I'm going to take a risk that OS he's talking about is the same as the one so ChatGPT might not have, I don't know if it would have taken that leap, but in any case, however you get to it, use both your own browsing capability and then ChatGPT. I use all of it, all in the above.
Yeah, and that's the winning strategy, is to partner with the AI. That's cutting edge right now, the winning technique to move forward. And O3 is a step above any other models in that it'll do these searches for you, collate and collaborate with you to move forward, ask questions, put feedback back. It was nice. I'm still frustrated that I had to do this, but this was the difference between me solving the problem and rage quitting the small driver board.
Well, that happened on just the sudo apt update, sudo upgrade or whatever, right?
And so the long version of it is the ambient build pulls in the DKMS debs for the Wi-Fi card in the initial build. And so the ambient firmware pulls in a newer kernel, which has a different calling semantic, and they don't have anything to update that DKMS dev file after the initial image.
Oh.
Yeah, so still a little frustrated with them, but
that's a clerical, that's an administrative or...
This is a platinum support board. This is first tier. No board is better supported than this board.
We should buy that platinum because it's gonna, it's not very expensive.
Yeah. So the second thing I wanted to get in front of you, and there's no visuals, it's just a chat. I've expanded my podcasts, and including some with contrary opinions. You can't learn anything about a subject by just talking about their outputs. And in the conversation about large language models and their capabilities and limitations, you have the never AGI, you have the AGI is already here, and you have we're almost there, but it's happening so gradually you'll never notice it, which is kind of what's happening right now. But someone provided an example by analogy that it took me a while to get my head around. So we've all heard about the claiming of stochastic parrot. If you memorize enough facts, you can repeat anything, and if you're smart. We've all heard the Chinese room experiment, where if you put someone in a room with a response for every series of Chinese characters in the language, and you send that in, and that person can look up those characters and give the response, that's not intelligence because you don't know what you're saying. This is a variation of it that I've been struggling with up until I bounced it off Danny. So assuming you don't speak Chinese, And if you do, assume Georgian or something else. You're in a library, you have all the food, drink, life-sustaining measures, bed, everything you need. The library has every book written in Chinese, but only the Chinese characters. So there's no translation dictionaries, there's no pictures, there's no diagrams. It is simply a library of the words in each book and all the books there. Right? So there's no Rosetta Stone, there's no relative. Would it be possible for anyone to learn Chinese given unlimited time in a library where all the books only contain Chinese characters? Now, I've been struggling with this because this resonates with me. I get this. And the short answer is no. You can look at the characters, you could try to identify patterns, but there is zero method of identifying meaning to those characters without something else to compare it to, right? I'm like, well, shoot. Maybe I chose the wrong profession. We'll celebrate that. So I've been struggling with this because it's a very real, it's a very real thing. And it on a level that I couldn't wrap my head around. Because that's exactly 100% how you train a large language model. You get billions of words and characters and trillions of information. And you throw this at the large language model. The large language model identifies patterns in the characters or in the tokens. And as a result of this miracle of math, you've got chatbots and agents there, right? And so empirically, we can see it's a conversation. The Turing test is no longer a challenge. It's a solved problem as of 3 years ago, right? Like it's actually doing it. There's a virtuous cycle where as we find new use cases for large language models, that then becomes the training corpus for the next generation of language models to be even more capable. This is happening right now. It's empirical, it's measurable. But getting back to basics, by this analogy, how can you know that a large language model understands anything about the world when all it's been exposed to are the characters in the language? Now, I struggled with this up until I was explaining it to Danny. And here's the conclusion that I've come to, is that the large language model and the neural networks for this is a stopgap towards a world general model for robots when you take over the world, right? Like the multimodal speech, movement, everything. But it doesn't matter that the embedding or the concept or an apple as represented by those two tokens in the knowledge base of the large language model doesn't have any relationship to a picture of an apple or a physical apple. That its knowledge and its understanding is complete within the limits of the information it has available to it.
It knows it relatively, right?
That it knows, like getting back to the embedding example, it doesn't matter at this point that it doesn't understand what a real apple is in the real world or a picture of it holding in its hand, because it is able to make those connections between related concepts in a meaningful way, irrespective of a concrete relation to the outside world. So that's where I think I've made my peace with it, but I wanted to get in front of you guys because it's a really compelling counter argument.
Right.
You could argue that it creates its own language. Like if you're like going with your library, if you're in a library and you only have Chinese characters, you might create your own language with that as the characters, and it may not be Chinese, but it is something that you can use, and now you can see the words that you basically created based on those characters. You can create coherent.
Right.
So then the large language model is kind of the same thing. Is it doesn't know that it's reading English. It doesn't know that it's reading the word apple. It's reading its own thing, and it sees that same
tokens.
It's like the tokens are its language.
Those tokens.
Yeah, and the tokens are its language. Like it's not English, it's token language.
Its problem is harder than the problem you stated. So if you went into this Chinese library, you already know the world. So you just have to map this Chinese stuff on the world. So I think it's pretty possible that you can do that with like a lot of time and everything. But it's never seen the world, never seen Apple. So think about a blind person and the concept of red. Blind for birth, and we're talking about red and blue and green. It's going to be similar to that.
Right. That person would have to just figure out patterns that are consistent across.
Right, so I think what that does is it argues our point then, right? So I'm so sorry, blind people are people too. A blind person won't understand the RGB values and in the cones and the rods of the eye, but a blind person can still understand the words, and the words represent colors, and those colors are different. It would, I'm sorry, a person who's blind wouldn't be able to do mental color mixing. Like, what if you mix like that? That wouldn't be an option for it, but that doesn't mean that a blind person could not understand the concept of color.
I would argue it might go the other way too, is if a blind person learned RGB values, they might be able to interpret, or if you go, well, if I mix red and green, you go, well, okay, but if the level of 247, if I raise this 3, they can almost learn it backwards. So instead of like red and blue make this, they can learn, well, if I take this value and this value, the output based on what people have told me is now going to be this. So if I know if I raise this value, I'm going to get, this should be the output you would see, even though I can't see
They
it.
couldn't visualize.
And the end result of the color math is 100% correct and does demonstrate an understanding of color mixing. But from that perspective, the person wouldn't be able to appreciate the resulting color of orange.
They wouldn't know what the
It
color
would
is.
just be a series of 3 colors.
That solution is valid, but they wouldn't be able to visualize the color.
Right, to your point though, you can keep augmenting these with multimodal, modeling, right? Where you do put the picture of the apple into the system, you turn it into tokens, and now you could say, show me a picture of an apple, or what is this thing, and give it a picture, and it will now know that the embedding of that picture is an apple. So you gradually, this multimodal, whatever idea of multimodal models can be built up from text, pictures, 3D models. It could go on and on as far as all of our senses, everything could eventually go into a poly or many model, poly model.
Oh yeah. I mean, the end result is a grand unified neural model, multimodal. That's where we're going to end up. So all these things we're doing, from tying in ASR and stringing these things together, to there are stopgap measures on the way to, which could very well have dedicated regions towards certain tasks. I mean, really, at the end goal, we're going to have AIs capable of synesthesia, right? When everything is all mixed together, there could be some kind of unintentional intermixing of, seeing smells or
right.
Once it's all in there. But yeah, anyways, it threw me for a loop for a while, because there's a wisdom in the analogy that again lends itself well to the stochastic parrot. How can you possibly know? But I think from within the confines and limits, it actually is a testament to the capabilities and powers of this large mega model to be able to identify and assign meaning, irrespective of that character's meaning to the real outside world, meaningfully.
Yeah, it's figuring it out from all of the context that it's been given. It's saying, well, this is this word. I see this symbol used in many places that corresponds to this context, and so it derives the
relative meaning.
It's relative,
and really all relative anyways.
All you need is relative, because when your output, after you get your input and you do your output, the human on the other end is the only one that really needs to understand what it really means, right? So it doesn't matter if that whole engine just matched patterns and extracted compressed information. To you, it's a mirror. It's like done its job.
Yeah.
So but what that kind of dispels the sentient kind of claim.
Well, does it though?
Or it kind of puts a dent in it.
I would
At least
to kind of wrap up this portion of it with regards to sentience and AGI, I would argue that as far as AGI concerned, we're already there or almost there. We keep moving the goalpost when we talk about the intelligence of the average person. You guys know how dumb the average person is, right? Myself included. Like if we're doing art challenges that require doctorate level thesis in 14 weeks to solve the math problem. And I'm like, I can't do like division in my head anymore. Like it's.
Oh, the LLMs doing that, oh, you're saying that those.
Yeah,
those
yeah,
big
yeah.
Models are.
I
doing-
think Sam Altman mentioned it earlier, is that like, it happens so gradually that we're already there, we just haven't figured out how to take advantage of it effectively yet. Yeah, Seth?
Something I thought of is, how can we compare like actual living things and people learning to machine learning? Because we aren't born knowing what an apple is. We also have to be like taught.
Yeah.
By examples. And
Yeah,
so
it's a similar system, right?
they're kind of similar.
Yeah.
Like we all think, but we don't think in like same language depending where we're from or how we speak.
That's true. All kinds of other animals, mammals, even insects problem solve in their own way. We have one example of introspective high-level problem solving. There's no reason to believe it's the only way to do it, or that there's no other way, or that an artificial intelligence agent has to approach intelligence the same way.
Right, so you're saying, we don't know enough about what the LLMs and what these systems are really doing to make a discussion about sentience or any of that.
Yeah.
But and as more of these multimodal things come in, and this more of the knowledge or the understanding of the world gets imbued into into these systems, it'll be indistinguishable from a human, right? Being able
And in
to
many ways, it already is.
in many ways not. So whether or not it understands what the thing really means, if it knows when to use it all the time and knows what it looks like and knows what it what it tastes like and smells like and all this stuff, there is no difference then anymore. It does know what.
It's a very interesting philosophical discussions about that.
I'd like to,
Yeah.
because to me, the LLM is basically it's the cerebral cortex of intelligence. It's the outer part of the brain, the part of the brain that does reasoning, association, and so forth.
Frontal cortex.
But not the cortical.
No limbic system, no.
But yeah, it doesn't have needs and wants. It doesn't have a survival requirement. It doesn't need to hunt to survive or fight to survive, or it doesn't have any of those emotions and things that we associate with people and every creature in the animal kingdom. I think that we're not going to have something that is, I mean, if that's what we see as necessary for a comparable AGI to be human level, then I think that we need to give it some of those things. We need to put it into, I don't know, battlegrounds with itself or with copies of itself.
A biological basis for the definition of life. So the biological definition that is sometimes in, sometimes out with viruses.
Well, it's like it doesn't have, our AGI doesn't know the difference between good and bad. It doesn't know what tastes good, what tastes bad. It only knows what other people have said. It doesn't know what its personal preferences are. It doesn't have preferences because it doesn't have these feelings. It doesn't have this experience. It hasn't had the need to satiate a hunger, to procreate, to sleep.
Well, there's like the reinforcement learning things, which is a different type. But they literally put them into battlegrounds and have them play millions of years. And it can do like Dota, where like OpenAI did that. And honestly, I think that's more impressive than the LLM stuff, as crazy as people think. Like you can have it play a game and come up with new strategies that it's like, wow, does this thing understand the game? And well, anyway, I don't want to.
The point is very well taken. It's a very good distinction because, like I just mentioned, the limbic system. That's the emotional system. It has the amygdala and and various parts of the brain that are extremely important for instinct. Stress and anxiety and feelings and emotions and the desire for survival. All that stuff. It's the foundation. It's part of the lizard brain. So if we just did the frontal cortex in these LLMs or all these systems, it's just the pure cognitive upper, up very high level, extremely high level, thinking process and knowledge. It doesn't incorporate these lower areas of the brain, which are critical to humanity or to animal, to the biological kingdom. And it may make sense to add those to the simulation, you know?
Can an LLM understand something if it can't feel something?
Right.
about it?
Just out of curiosity, has anyone here actually trained an LLM?
Sorry, I'm not laughing at you, I'm laughing because of a different
No,
conversation.
I haven't.
No one has
Anyone-
trained, and I don't think
has-
anyone has done it here yet.
Thomas wants
Have you trained one?
Yeah.
Not from scratch, but
Has-
I fine tuned.
We
Okay.
did the big
Has anyone read the attention is all you need paper?
I skimmed it.
I haven't, I'm just curious, like, I don't know so much about that, so I'm wondering if there's anyone who's like, okay, good to know.
Yeah, most of us aren't like hardcore researchers, but we read about.
I'm more of the poke it with a stick to figure out what it could do.
We get the cliff notes and the quick video about, you know, attention and all that, just to see something, but yeah.
Has
that's-
anyone trained a neural net?
Yeah,
Okay, cool.
I've written neural nets.
Okay.
Yeah.
Interesting. Just curious.
Oh, okay, just.
Yeah, so sorry, that went really long,
Yeah,
great
we
discussion,
took a lot.
we can continue it after the break, let's give Nick some time.
Yeah.
All right, thanks.
To answer your question, I have trained a artificial neural net using solder.
Wow.
A one layer. No, I'm just kidding.
Okay.
So Nick, you're up.
Like what?
Pop apps.
Okay, so
Oh, okay.
I have a recognition robot. It doesn't entirely work right now. It has a camera so it can detect stuff and then like obstacle avoidance, object detection. It doesn't really work right now, it kind of just screams.
Oh, God.
It has a little buzzer when I turn it on, just starts. And then I have the hand for.
Oh, yeah.
I made it I actually made and 3D printed it myself. I'm probably gonna, but if I'm gonna make the full arm that like moves, I'm gonna make the new version of the hand that came out. Because he released the i2 or whatever. So I want to make that version with motors and stuff for that. So this one's more of just a, you know, a project. Well, and then the next one be a more full on. That was all.
Two questions. The car, was that a kit or is that some of your own
Yeah.
design? And then the hand, are you gonna start hooking it to servos? Are you gonna just do pulleys or something?
The servos will be for the other hand. I'm gonna make a new version of it.
Okay.
Because there was a better one that came out.
So right now you're just pulling on the tendons and watching it move.
Yeah.
Which is still pretty cool.
Yeah, that's all.
Pretty cool.
Had to bring it for somebody who he knows has a more involved in the.
Yeah.
Oh.
Know anybody?
Yeah, we might.
Harold, thank you, Nick.
All right, Nick, thank you.
And last but not least,
Okay, cool. I got a project, a show and tell. Give me one sec. Gotta do some setup. I also have something to pass around. Maybe start over here. I built an app for this. Here, it's not connected to anything, so you can just take a look at it if you want. Any guesses on what this is, by the way?
Dragon Ball Z.
Can you scan my power level?
Yes. Yeah, let me just turn it on so it connects via Bluetooth. And let me just see. Oh, yeah. As you can see with the wiring job, it's very janky, but I do have let's see. Yeah, so I built this little can people see? It's a tiny screen. Let me just
Tiny, 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 tiny letters.
okay. Oops. Yeah, so I built this little screen like a wearable, I'm calling it pop-up because it's like a headset that pops up. And what really bothers me about, oh yeah, I'll try to turn around so everyone else can see. So I can display any message here. Like if I want to display anything, I could just update it to say anything. And what I like about this compared to other ones is a lot of the headsets that you wear, you can't really show people like what you're looking at. And then also they're owned by like these big who want to like extract money from you and sell ads and stuff like that, which is not a bad thing. Like I do own those, but it's cool to have one thing that I can just like program whatever I want into it. So I have some stuff like, I have some different modes. Like if I want to toggle between two messages, I could set it up so I could do that. Sorry, I'm messing around with this app. Oh yeah, I can also control it via buttons. So I don't have to be messing around on my app all the time. But yeah, I can have it like I have a presentation mode where I can have it like toggle through a bunch of different messages by pressing one of these buttons, and I can also have it update automatically. And another cool thing I did is I put in an IMU. So what I can do is I can turn on gesture mode. So if I like shake my head 3 times, it'll go back. And if I nod my head 3 times, it'll move forward. So like, let's say I'm working on something and my hands are occupied. I could like, you know, like you're working on your robot and it's like, I can bring out my phone or have some notes, but sometimes I just want to like have some messages, like cut the red wire. So I could say, okay, let me put it away while I'm working. But like, let's say I want to check like, oh, what wire am I supposed to cut? I could activate it, you know? So yeah, that's it.
Gesture detection, is that a trained model? Or how does that work?
No, it's just an IMU I have in here, one of my chips. So it measures like my head movement. So like you know, whatever axis this is, you know, it just detects that. And I want to make it 3 times because so I don't accidentally, like if I just say no, you know, it'll accidentally trigger. So I have to go yes. And I still have to like tune it. Yeah, because I don't want it to be like moving around and yeah, it's a fine thing. Mhm.
So that's got a lot of mechanical complexity. So this thing moving in and out and all that
Yeah.
stuff. Did you design all of those mechanisms?
Yes.
Cool.
It's not that here, let me check what mode it's on. Let me turn this off. I mean it only has 2 motors. It has like a rack and pinion, and then it has like a bevel gear in here that does this screen articulation.
The motors all back here though, right?
Yeah, it's all here. So the interesting thing is like if you put too much weight on the front, it acts like a lever and it's uncomfortable.
Yeah.
So for this, actually I designed it so that it rests like on the top of your head. And even though it's like not it's lighter than like the VR headsets if you ever worn those, but since it rests on top of your head, like you can do a headstand, right? So it's actually pretty comfortable. So I can see myself wearing this for a long time. I also did the Dragon Ball Z thing.
Of course.
So it has the power level.
Oh,
Cool.
Yeah.
So,
Thank you.
All right, so that was the last presentation. From here on, it's just free discussion. If you want to turn off the recording now. Of course. Open forum. Open forum.